really important here is that you want to include the possibility of rollbacks. So with the Ansible collection, you also can use roles for doing LVM snapshots, VMware snapshots, basically to allow for snapshotting the system before the upgrade and then rolling back quickly if anything goes wrong. And this has been used with many Red Hat customers at scale with thousands of systems using the Ansible collection. And the idea of the fail-fast approach is based on just not being afraid of committing to the upgrade, just trying it in iterations, finding inhibitors, playbooks, then doing the upgrade, and if anything goes wrong, roll back. And yeah, it's no need to fear that. And yeah, you wanted to add something?
You should also do a backup without using this approach before every upgrade.
Good point. Yeah, always do the backup. It's not a silver bullet solution that would solve all the cases there are. So where you can find Leap, that's as Maciej said, it's in AppStream repo of CentOS Stream 9 currently, and you can also take our developer builds to get the cutting edge versions. And also you might wonder if you'll be able to upgrade even after the end of life of CentOS Stream 9. Yeah, you don't need to stick to the version that's gonna be the last one in the CentOS Stream 9 repos. We'll have a publicly available repository where we'll be publishing new versions of Leap that we regularly test. So you could then keep using those and updating those even past the end of life if you just miss the deadline, let's say, and you want to upgrade later. Yeah, it's just links where to find the code, where you can file the issues you find, and some documentation.
One thing I haven't mentioned is Lib is actually a framework, and we have upgrade components which the framework runs. But if you want to report some issues, you should regarding the upgrade, you will very probably want to upgrade report them on the upgrade components repo linked here. It's called lib repository, which is confusing, but that's the one.
Yeah. All right. Yeah. Thanks. And yeah, sorry for not having that much time for questions, but any question? Please go on. Oh yeah, the microphone. Yeah, please. Thank you.
So this is very cool, and I'm very excited about the idea of being able to do upgrades and conversions in one step, because like it could seriously reduce the time that it takes to do this. But I was wondering if you would consider being able to like offer hooks or integration point for being able to do things like snapshot the system before we start doing stuff, because if it goes horribly wrong in the middle, you can at least fail back to this and figure out what's wrong and try to figure out a recovery strategy or something like that without essentially torching the system completely.
Right, yeah, good question. We've deliberately haven't included snapshots or backups into Leap itself, because there's multiple options or configurations of your system. So you can have like, for example, we might want to do LVM snapshots, but you don't use LVM, so this wouldn't apply. Or so basically, what we've decided for is providing all the Ansible playbooks to choose the best backup option for you. So we've got the Ansible roles for LVM snapshots, VMware snapshots. There is also the rear end relax tool So you can pick and choose what you like the most. And yeah, also, if it's in the Leap itself, you might rely on it too much, and it would be quite a big burden on us to make it really reliable. And well, I wouldn't stick my hand into the fire, or how we say it in Czech, that it would really work.
It's not that different in English.
Right. So yeah. So we've got, but we with the in the Leap in the infra.leap collection of Ansible playbooks, we link to the other roles for the snapshots, where yeah, for the backup and rollback.
Sure, and that makes some degree of sense, but the reason I was asking about like a hook is because then it scopes out from you, but like if it's set up, like there's something that it detects as a file or a command or a config or whatever, then it can just run it before it starts doing anything. And then you have the snapshot that was governed the way that the computer itself already has it.
I'm not sure if I understand. So
As a pre-step, before you start doing any real actions, if you detect that there's this particular configuration that says this is the step you need to run before doing anything, someone could configure that to invoke the snapshotting or backup or whatever mechanism. That doesn't make it on you, but it does mean that like this is an aspect of Leap that can work for especially interactive usage of it, which is, in my experience, the most common way it is used. I mean, that's, again, my experience. I'm not saying like that it is in absolute terms, but from a user experience perspective for an interactive one, having it where like, for example, we in Alma Linux, we might want to have set up a hook for like, hey, if you're on Butterfest and you're doing an upgrade with this or whatever, then we want to take a snapshot and then roll up into the next release through this. And if it goes badly, then you can just hit the rollback button. Because for us, the interactive case is the dominant one.
Not sure you can use Butterfest.
yeah, it makes sense, but frankly, we focus more on the upgrades at scale, the non-interactive ones, because, well, that's at least what because we expect a lot of companies to just decide let's upgrade our fleet, and that might be hundreds and thousands of systems. So we try to make it easy to automate, let's say. But yeah, the case you mentioned, it makes sense to make it interactive for when upgrading one or a couple of systems with some hooks like that. But
I mean, the hook could also work in the non-interactive case. The point is that it doesn't have to be something you code up specifically, but if there's an entry point that someone else can plug in that, then Leap knows to use it.
Right. You can also just script it, a little bit scripted the way that you run pre-upgrade and until you are satisfied with the output, which you can script, and then do it, the backup. But also, I don't want to interrupt, but are there any other questions because we are running out of time? Okay, no, but we can talk about, after the talk, if you have any questions, we will be available. Yeah.
I have one.
sounds good.
You have time?
Yeah. We?
It's perhaps a bit naive, but maybe you could give me some context. Is there a reason why we should or shouldn't maybe converge what the upgrade process in Fedora is with CentOS and stuff like that, just so that it, does that make sense to do it? Is there a reason we should or shouldn't? Is there, maybe you could just put some context. That would be great. Thank you.
Yeah, so the upgrade in Fedora is much easier, as you can rely on scriptlets. There's not that much of a difference between the major versions of Fedora. But it
Yeah.
We test that in RHEL. We test that packages can be updated, and also between major versions, we asked maintainers to ensure that also packages can be upgraded from one major version of RHEL to another. So that's what we do before the release, ensuring that the packages can be upgraded. But yeah, we also thought about integrating Leap into DNF. So when you run DNF upgrade, well, what's system upgrade? Yeah, that would on rel invoke Leap under the hood. So
And
that's one thing that we might do in the future. But
it's the other way around actually right now. We have a DNF plugin, but we also have this lot of steps around it, around the upgrade. But also another reason why the leap was made was because in Fedora you don't have that many repositories. And in RHEL the ecosystem of repositories is like really vast, and we need to make sure we enable the correct ones, handle cases like splitting and merging of not only packages but also the repositories. And the same is true in CentOS Stream to an extent. Yeah, that's also one of the reasons. But the bigger one is that we don't rely on scriptlets. We have to do all of the work.
I'm glad you're working on this. If in my mind, at some point, if Fedora converges to more what you're doing, or vice versa, I think that would be a good thing to have one, one process for everyone, whatever that process is. Thank you.
okay, thanks. Good job.
All right, we'll get our next speaker set up. Mauro and Gregory will do an amazing hardware demo for us to test
Or an amazing fail.
the live demo gods today.
I'll probably take that one.
I'll take this one, it's fine. Yes.
One. Can you hear me? Yes?
All right, everybody. I will just get the live stream running again. And please welcome Mauro and Gregory to talk about amazing home labs with CentOS Stream and LXD.
All right. Hello, everyone. Welcome to our talk. Before we get started, we want to say a couple of words about the speakers. So, hi, my name is Mauro. I'm Italian. I live in Switzerland. Some of you might have seen me running around, organizing or speaking at some events. If I'm not doing that and I'm not being a mad scientist in my home lab, you'll probably find me hugging plants, as you can see there, or learning the ancient archery ways of China. So, green thumb or thumb ring, that's me in a pinch.
Hi everyone, I'm Gregory Schiano. So I'm French and I live in Belgium. And yeah, aside from that, I'm a big fan of Japan. So been visiting the country many times. I'm a proud father of 2 kids, a daughter and a son. And then I like partying everywhere in the world. So here I'm in Korea with some colleagues. So today, small parenthesis. So today it's talking about LXD, but since we're that kind of guy, we're doing a live demo. And since a live demo is too easy, we're doing it with bringing our own hardware. So quick word on the hardware. It's a small board developed by one of my colleagues. You cannot find it anywhere. But it allows you to run 3 compute modules. And on that one, I have 3 Raspberry Pi 5, 16 gig of RAM, 12 core in total, and 32 gig of eMMC. And on the other side, I can put 3 NVMe, and on that demo, I have 3 times 2 terabytes of storage. So in a passport size board, I can run all this. And I will run the demo on that. So while Maro is talking, we'll make sure that everything works and boots up properly, and then I will do the live demo afterwards.
All right, thanks. So, why are we here? Why are we doing this? First of all, CentOS Stream is awesome, but please don't tell our boss. LXD is incredibly flexible and powerful project. We are geeks. We love home labs. We are self-hosting, single sign-on systems and doing crazy stuff, and this is a lot of fun. And then we thought these 2 technologies put together are a great combination to teach open source technology to the next generation of FOSS leaders. Last but not least, we heard rumors that Graham might be still running CentOS 6 in his home lab, and we felt the obligation to do something about it. So, Graham, we know, we're watching you, now you have to do something about that. All right, so let's have a look at the agenda. We'll cover some of the basics. We'll give you a quick introduction to LXD. We'll have a short report of advocacy and reception, and then we will have the real question, will it CentOS or not? We'll give you a report on our journey, what worked, what didn't. Then we'll think a little bit about what would be amazing, and then all pray to the demo gods, and Gregory will show us a quick demo. So, let's get started. So, raise your hand if you know what a virtual machine is. Yes? Good. All right, not much explaining to do. We all have fun with virtual machines. That's a quick picture for you. You can emulate a full operating system with its own kernel, and it simulates a real computer inside another computer. That's really cool. Raise your hand if you know what a system container is. Yes. All right, we're not spending a lot of time on this. It's basically, we can briefly describe it as a mini VM, a little bit less isolation, a lot less resources needed, and must share the host OS kernel. Now raise your hand if you know what an application container is. Podman, Docker, yes, good. All right, this is not really in scope of LXD, but we will make it in scope, and we'll work around the systems. And basically, it's even less consumption hungry than a system container, because you're just containerized the minimum application and packages that you really need to run. Requires a runtime and the host OS kernel. Right, so then what is LXD? So LXD is an open source solution for managing virtual machines and system containers in one single place. It has a really powerful CLI, but also it has really, really good web user interface. So it's really powerful and it's really flexible. So you can install it on your laptop and do VMs, system containers, like you would do in other system targeted to a laptop. Same thing, you can dump it on a rack of 50 servers in a single cluster, up to 50 servers, and then you can have fun with all that. As we can see here, we can we have this massive benefit of having a single platform that can do multiple things. And in LXD, we call VMs or system containers, they're just instances. So they share the same name, and then your scripting thinking will say, oh, that's good. I don't care if it's a VM, if it's a container. I can do all my things in a very transferable skills and intuitive commands. So you have one single place where you can configure your networks, your storage, volumes, one single place where you can do your automatic snapshots, your backups, auto start, auto stop, and it's one single place. So from the storage department, it's doing pretty well. You can configure storage from the simplest one is a directory. So if you're on your laptop and you don't want to think too much, you just say this directory is my storage. It's not really powerful, but it works. You can do LVM, you can do Btrfs, you can do ZFS, you can do Ceph. Especially if you are clustering, you should think about these things. There's a few more, but these are the heavy hitters. Networking side, it's pretty cool. You can do bridges, you can do Mac VLAN, you can use Oven, especially if you're clustering. You can do physical network card pass-through if you need it. I do this when I virtualize my firewalls, for example. And you can do other things. For example, inside LXD, you can configure access list, BGP, servers, port forwards, network zones. The rabbit hole is really deep here. So this is a web UI. I'm spinning up CentOS there. So yes, there's a CLI. That's how LXD started. So for all your advanced scripting madness, you can go pretty mad with this. However, the beauty of this is that you do not need to be a system admin professional to figure it out. This web UI, honestly, nowadays there is not much that you cannot do just from the web UI. Some of you might find a way, Neil, I'm looking at you. You'll find a way, but it's pretty powerful. So, I know, Podman, Docker, Kubernetes, we all want that. Let's see. So the short answer is yes, you can. The obvious way and the lazy way is you spin up a VM and you put your Podman or Docker inside it. It's not very inspiring. We all know that you can do it. Let's see if we can do something better than that. So the best way here on LXD is you can spin up a container, which uses way less resources, and then you can use that as your Podman or Docker host. You need to tweak a couple of flags in LXD, but that's perfectly supported, and it works. You want to go further than that and make a little bit modular in your home lab, you can create LXD volumes and mount these volumes to specific Podman or Docker containers so that you can have a little bit more flexibility, a little bit less than a monolith system. You can even map Mac VLAN networks at the LXD level to specific Podman or Docker containers. So if you want a flat network and you don't want to figure out double NATing, crazy routing, and things like that, keep it simple, it works, and that's a proof. That's a screenshot from one of my home labs. As you can see, there's LXD VMs, especially for the firewalls, a lot of LXD containers. One of them here is running Docker with a bunch of stuff that is honestly easier to run on Docker than working a week to build it on a VM or a container, so lazy way wins all the way. And you can see there that I'm mounting specific LXD volume to specific containers, so my backups are a little bit nimbler, I can change my mind and move things around and scale up a little bit easier. All right, so what have we done about this? 2025, Ubuntu volunteers and canonical people, we've been going around the world speaking about this and especially giving workshops. That's one in Nepal. The room was for 40 people. 10 minutes after we started, we had 50 people in the room trying to get done. And everyone was there, everyone was struggling and asking a lot of very difficult questions. At the end of the workshop, everyone walked out with an install. And there are other instances where we're giving demos and workshops. So far, the reception has been really good. Yes, good, but now the real question is, we ask ourselves, will it CentOS? The cat is really curious there, so let's see what happened. So yes, we're here, of course. The short version is yes, it will CentOS. So that's really good. Actually, it was easier than what we thought. You just need to, well, install CentOS. Then you need to add the Apple repo. Install and enable Snapd. Start the Snapd service. And yes, I see some eyes twitching there. Yes, I know. Are you looking a little bit like this? I see some eyes twitching at this moment. Yes, well, if you're looking a little bit like this, try to think about how the organizers of this event, who accepted this talk, might be feeling in this moment. Maybe a little bit like that. Sorry. I'm fine, I promise, this is fine. All right, but seriously, why Snapd? So, Snapd containerizes application and it can run system services. It avoids you dependency hell. You can decouple your OS from the version of LXD that you're running. You can move across releases of LXD fairly easily. So, are you brave? Do you want to test something that is still, in Edge channel? You can go back and forth. There's a major word of caution. Yes, you can always upgrade. If you're sticking to a minor release upgrade, so no problem. If you're leaping forward crazy, like from 5 to 7, there might be database upgrades that will then prevent you to rolling back completely, but you will be warned. You can do snapshots of the snap. The words are a bit confusing, but you can. So it's very portable. You can, with one single command, take a snapshot of your all crazy configuration of LXD. You can get very, very complicated. With one command, you can zip, and then you can dump it on your server. Or you get a new machine, zip it, unzip it. All your crazy stuff is back there with one command, not including the storage, because it will take 20 years, depending on what you're doing. So storage is not included, but all your configurations are. And then, now we'll talk about this a little bit later, but this is, at this moment, the most complete and the only complete and updated feature set of LXD that we could find. And not only in the Red Hat world, we tested the Debian packages, Arch packages, RPMs, and sadly, for now, that's the only way to go, so sorry. All right, are we good? Yes. I like this, so this is yes. So, what went well? Installation, okay, worked. We could install LXD, Snapd, LXD works on CentOS real easy, so thank you for the work. Init of LXD worked, and it works. There's an asterisk there. We'll mention this in a second. Wow, SE Linux. I was sure that it would throw a stick in my wheel, and it did not. I'm like, okay, that's pretty good. I don't know who did that work, but thank you. And again, quite surprisingly, clustering worked pretty smoothly. So now, yes, if you go and try to look, install LXD on CentOS and you look at the documentation that someone from this side of Linux wrote, there should be improvements to be made over there. This is the asterisk about the init, where if you install XD on Ubuntu, it will default when it asks you, do you want storage? It knows, oh, you're running Ubuntu, therefore we think that DFS is the best for you, because Ubuntu supports DFS really well, next, it works. If it detects a CentOS, it will say, you want Btrfs as your storage, and then next, and it fails in your face. Just like that, with no really specifically clear messages on, yes, it's about the storage. We tried it with loopback files. We tried it with dedicated partition. The answer is no. You switch to LVM, bam, it works. So it's not a problem of the init system. It's a problem of somebody thought maybe it's the same as Fedora or something like this. So we should do something about this and change the default when CentOS is detected. So if you want to have a chat with us, that would be great. And the last one is that there are no CentOS Stream 10 images currently for LXD. We installed the CentOS Stream 9 in the demo, but if it's a VM, you can use custom ISO, but room for improvement, I would say. So we're thinking, what would be amazing here? First of all, maybe for those of you who were twitching just a little bit earlier about the snapd thing, I don't know, maybe an RPM that bundles LXD would be good, so you can run it and you don't need to install snapd. We would love for somebody to, create and maintain CentOS Stream images, so people can just go to the web UI and say, give me a container, click, 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 I want CentOS Stream 10, and let's go. That would be good. And so remember the advocacy slide just a few minutes ago, and we think that it would be amazing to think about this beyond Ubuntu. I think that would be great if we all think about helping the next generation of open source engineers, enthusiasts, leaders, help them skill up. Use these. We're not here to sell a free product. When we go to do all these workshops, we do the workshops with the goal of teaching technology to people. And LXD is a mean to reach a goal. So I think that it would be great if this or similar things could be cross-project, cross-distribution. And of course, LXD is an open source project, and they're willing to take code contributions and non-code contributors. The team is really awesome there, and they'll be happy to work with you if you want. All right, we are approaching the end of the talk part, and just quick reminder, as I mentioned, LXD is made by a group of really passionate people. It's an open source project that encourages collaboration and contributions. So for all your LXD needs, you can head to the orange QR code or the link above. You will find links to forums, documentation, and other resources. If you have specific issues or feature requests, you can use the black QR code there. And that brings you directly to the GitHub repo, and you can see what's going on over there. So that's it for the talk session. I'll hand you the mic and see what happens.
Okay. So I've been sweating a bit because it didn't start from the beginning, but now it's working. So the idea is that I'm doing something fun. So it's installed with microcloud here, which is just a bundle of LXD, Ceph, and Oven, because I don't want to reinstall the whole device every time. So microcloud is running on Ubuntu. On top of it, I've made a LXD cluster of 3 nodes using CentOS. And on top of it, I'm running CentOS and Ubuntu containers. So I'm doing CentOS on Ubuntu. So this device is getting quite hot, needs to be optimized. So Mauro will have a very technological device that will make sure that it doesn't get too hot.
With the power of my coding skills, I'll keep this device cool.
Yes. The display. Yeah, the display. Yeah, it's going to survive. Okay, just changing to mirror so I can see what I'm doing. So let's start with the lower level. So authentication is done through a certificate. So you need to have a certificate on your browser to authenticate. So here the certificate is there, and I can authenticate on it. So I'm on the microcloud UI, and here you can see that I have, it's loading, I have 3 CentOS LXD instances currently running. These are my other demos, other virtual machine that I'm using for the demos. And just quickly showing you that it's running on the 3 nodes, and that the nodes are ARM64 with a little bit of hardware here and there, so 16 gig of RAM, etc. And then I have a safe storage of 2 terabytes because it's, yeah, it should be a bit more. I don't know why it's 2 terabytes. Weird. Never mind. So on top of it, I have these instances, and they are running the LXD UI. So I can refresh here. So the main difference here is that it's running microcloud, and this is running LXD. And it's running on the 3 VM that I showed you. So I will SSH to it. Oh, I don't have the terminal. Mauro, can you start me the terminal? Oh yeah, you have it there, okay. Sorry. Okay, so I'll SSH to, I'm SSHing to one of the VM just to show the proof that it's running CentOS.
Or not?
Yeah, I didn't put your SSH key everywhere, so that's okay. Just need to SSH to the right node. So I can cat. So it's running CentOS 10. I'm not lying. And then on top of it, I'm running 2 virtual machines. So 2 containers, I cannot do nested virtualization. So I cannot start a VM inside a VM inside a VM. So these are just containers. It would be fun, but yeah, okay. It's ARM and it's still limited. So here I have one CentOS 9 container. So as Mauro said, unfortunately, CentOS 10, there's no images. I have one CentOS 9, and just to prove that all the nesting works with the network, because I'm using bridges, I can ping, so I have access to internet. And then I have another virtual machines here, which is an Ubuntu one. Okay. So it's reading Ubuntu 24.04. So basically, I'm running CentOS in Ubuntu, or Ubuntu in CentOS in Ubuntu. And I think we're on time. Do you have time? Do we have time for questions? Yeah.
So Mauro, you mentioned that you wanted, what things that would be amazing to have, and one of those was the CentOS Stream 10 LXD images. Have you considered talking to Troy of the Alternative Images group to see if they could make one for you? Because that's kind of his shtick.
That would be great, yes. We just figured out as we were preparing the demo, so we thought let's go there and see who we need to talk to, so thanks.
They are already on images.linuxcontainers.org. my teammate fixed that like 4 months ago. Is that not the same thing LXD uses?
Not really, but they're probably the same thing. So perhaps so the project was forked. It's basically almost the same thing. Actually, both sides are cherry picking patches. It's probably a copy paste. So ideally, it would be good to set up a efficient way of sharing those images or just not replicating the work. So maybe we can have a chat. Thank you.
So, from my understanding, LXD uses AppArmor to confine the containers, right?
Yeah.
And CentOS, I don't think it has its AppArmor enabled, or does it?
It does not, but it has SE Linux, and I worked with Stefan several years ago to enable SE Linux confinement in LXD.
That one answers my question.
You want to?
I wrote the policy for it for container SE Linux, so like, I see. So I know that it was there.
Good. Yeah, thanks.
Thank you.
Thanks.
Well done.
All right, we'll get our next speaker set up. We have one more speaker before the break.
Do you need help?
Do you want this? Got it. I'll hand you this one.
And then the hope would be that there's going to be like, is there someone that walks around with a microphone for people?
Yes.
Okay. It'll be obvious when that time starts. I'm hoping for this to be mostly interactive. Does this need to get turned off for it to not horrible echo?
Oh, no, you're all hearing everything.
Lovely. I just didn't know if it would echo with having two microphones right next to each other that are on.
We haven't had an issue yet, but we can.
Try and see.
I can pull it over.
I'm just not going to use it. I don't care.
Okay, our next speaker will be Callie Dolphy giving us a talk about community data analysis. So please help me welcome Callie.
Hello. As a little bit of a start off, if community data analysis is something that you would like to talk about, this section, like I'm hoping that this talk is going to be much more interactive than me just speaking at you. So I would let people adjust, maybe come to the front if that is interesting. If not, I can talk to myself. I'm good at that. So about me, I am Callie Dolphy. I've been working at Red Hat for about 5 years, working on all things community data analysis. I'm from Texas in the US originally, and I moved to Boston, and I have been there ever since college. Outside of doing data analysis work, I like to ski a lot. That's usually where you'll find me during the winter when I'm not at one of these events, cooking, all those good things. So, the goal for today, and we're gonna have a table section during lunch today about this overall topic, is to leave with 1 to 3 questions that can be answered with the data currently available from CentOS by the end of 2026. These questions that we'll leave with, I want it to be something that we know that the data already exists, so it's a tangible goal for the end of this year. So I wanted to bring up this quote. This is something that has been discussed a lot. I was just at the CentOS EU yesterday, which is a community that focuses on all things community data analysis work. And this quote was discussed a lot, as well as lots of different community data analysis. And It's that metrics are not always the way to answer questions. They're a way to figure out what questions to ask. How do you navigate a sea of information to choose what to focus on, how to lead initiatives, and different things along those lines. So the first thing that I wanted to do was go through some of the conceptual building blocks that I like to think about when looking at community data analysis. This is a framework. Kind of, if it works for you, great. If it doesn't, I'm open to having a more unstructured conversation about what questions and metrics would work for CentOS. So, as a little bit of a process, the first step I like to think about is breaking down your focus area and objectives. If you remember the magic 8-ball, some people might have had that in your childhood. You'd ask questions, you'd shake it, and imagine it could give you the answer, any answer that you would like. It'd answer any question. Kind of do that thought experiment. For me, it'd be something like, will it ever snow in Colorado again? And it would shake it, and the answer would probably be probably not. And next thing you'd want to look at is what is the data is available. That's also like an open discussion I want to have either now or at the table of what data is available around CentOS and help that guide the conversation of how we would go from the high-level magic 8-ball, if I could answer any question, what would it be, to breaking down the question into sub-questions that can actually be answered that would bring you closer to that proposed magic 8-ball question. From there, we're going to be going from converting that question to a metric, and this would be a process that you would repeat for each part of step 1. First, you want to determine for the following proposed questions, which is what specific data points are needed, what visualizations could represent this data, and what actions and insights could come from this. And from this work in progress metric is when we want to get more community feedback, say that this is the process and point where it usually becomes its best form. A lot of times that initial idea would inspire somebody else to come up with something that the original person would never think of. And so that's where I'm kind of hoping our table discussion today would lead us. Next, we'd want to look at this analysis in action. First thing we'd be looking at if it aligns with prior knowledge. Is this, like, what are the assumptions that lead to this prior knowledge? Is something misunderstood about the community, or is it that there's a data problem? Is there something inaccurate with the way that we're collecting data that is making the analysis to become skewed? It really could lean each side. From there, we would want to implement community initiatives that are informed by this data analysis. Those initiatives should be measurable so we can see their impact. And from there, we would want to observe those community initiatives. Are we measuring the right things? Does the initiative itself need to change? And it's kind of a process that will go from there. So one thing I did want to talk a little bit about is some examples from other communities. And that's actually, I went around at ChaosCon yesterday and tried to talk to different people about their own experiences working within communities, developing it within communities to analyze itself. A lot of times my experience is from the perspective of working at Red Hat and analyzing communities that I'm not specifically involved in. So talking to different people, one thing that came up a lot was looking at the conversion rate to a first-time contributor to a consistent contributor into the community. What is that conversion rate? Is there different things that could be done within the community to make that a better process for people, more welcoming, more people converting from that point? Another thing that we were talking about is something called the love orbit model, which is looking at the weights of the number of contributions a person does, the types of contributions, and how long it's been from those contributions to see what contributors are kind of pushing near the center of that community. As somebody who maybe is a community manager or more active, are they aware of all the people that are kind of navigating around this love orbit model? Is there more, does somebody need to get promoted to a maintainer status? Is somebody who is actively involved in the community and may be ready for a more leadership position? These are kind of two of the major examples that came up during this and might help people kind of situate of what is done in some other communities analysis and how that would actually impact the way of going, something that could change about your onboarding process, how it could change maybe the promotion process for maintainers, more of the analysis and how it actually goes into action. So this is the end of me talking to you. Please don't leave me hanging. The things that I would like to kind of bring up and want to get people in the crowd, would like to kind of have an open conversation. The two things we would be talking about at this point is what are the questions that would be useful for the community to have answers to. We can be as pie in the sky as we want to about this at this point. Talking about anything with a little bit of data in mind would be helpful, but I'm just looking for interaction. And what are the data sources that we have available to us? All that I know of right now is the repository information, but there might be other data sources that I'm not aware of. I'm just here to help guide with the knowledge that I have. I want to let this be as much of the people who are actively involved in this community day to day, rather than it be myself guiding this. So this is my pausing point. We'll see, is there anybody who would like to mention a question, a data source that we have for CentOS? Yes.
Hi, so this is from the perspective of somebody within Red Hat, but one pet peeve of mine is that we should really do a better job of actually shipping the binary packages that fix CVEs, and the way that the process works in actually shipping the package, the build package into CentOS Stream, it can sometimes be forgotten by Red Hat teams to make sure that that also happens. So I think we have all the data available. There's the Brew Hub, and we have the data from ProdSec on the CVEs, and we have the internal Red Hat Brew instance. So we could theoretically set up a dashboard that tracks all of those and notifies us about it, but I'm not aware of anything in that area actually existing right now. We built something for us, for our team, for ourselves, but there should be something that tracks the entirety of CentOS Stream.
I really like that. It's actually an idea that I've never heard of before, even like outside of this context. And it sounds like something that is pretty tangible, that we would be able to measure and would be able to, actually make something actionable by the end of this year. If you're interested, please come. Let's talk about it on the table. I'd like to take some further notes and we can get this actually started. I think that's a really great one of the potential questions that we could do. Yeah.
Hi. As a person at Red Hat, I'm curious, what is the percentage of CentOS servers that are being used in production versus development? That's something I feel like we shouldn't be able to know specifically, but we should be able to guess at. So
how would you, what would be the guess, what would you think that would be like a signal to that?
People that are downloading and spinning up an instance that is long-lived versus short-lived. So the count me flag is from a non-unique thing after a week, right? Machine's been up for a week as opposed to 5 minutes.
Okay. Is there like a call, how would you be able to get it for individuals? Is that something that you opt into?
So count me is opt-in for Fedora, and I believe it's in CentOS as well. Somebody want to correct me? I see a nod.
This type of thing dances along stuff that can be a little bit controversial to measure, especially around downloads. So I'm curious to have a little bit more context.
We have this data actually.
Okay.
So the count me is turned on by default. You get this data if you go through the mirror network. So if you have an organization that has private mirrors that don't go to the mirror networks, they're invisible, but everybody else shows up in count me data. We have graphs, and we actually already have the long-term versus short-term. I believe Troy or Carl can point you to where the graphs are, because they do exist and they've been shown in talks before. On the data sources point, I think it would be interesting to see, because you have kind of two classes. You have CentOS Stream specifically, which is under GitLab Red Hat. And then you have CentOS, the content from the SIGs, which is for the most part these days under GitLab CentOS, but there's still some stuff on other trackers that's going to move eventually. What I would be interested to see, and what I tried collecting in the past to like limited success, is for the CentOS stream, how many contributions are coming from non-Red Hat, and what is the time to like for non-Red Hat contribution, how long does it take to get things merged? How many like back and forth are done PRs? Like I think this will be good metrics for community health. Obviously, it's going to be overwhelmingly Red Hat employees, but I think for the part that is community-driven, it will be interesting to see what the focus areas are. As somebody that is involved in CentOS and is interested in these. On the SIG side, I think you can probably get basic community health metrics there, but I think frankly a lot of the SIGs are too small to give you meaningful measurements, but it could be interesting to see as well.
Yeah, I really like the idea of looking at time of response for people who are not at Red Hat. This is like a type of analysis that's pretty common in all types of communities where there is a major corporate involvement, trying to see if there is people who are not involved in that company, is it a welcoming process? Are people getting the response rate that they're needing? I think, yes. I think this is a great idea, something that's super tangible. I'll say again, if this is a conversation you'd like to continue, please come to the table. Pretty much what we're talking about here, we'll be working through during lunch and seeing how far we can get, like setting things up so that it's realistic for this year. Yeah.
Hi. I actually would love to see this broken out, like response time or activity for each SIG, because basically once a year I kind of go through and I like, is this SIG active? Is their information still correct? That's manual, whatever. But like for me to be able to look and see, I know hyperscale SIG is active, but like to look and see which ones still have a lot of activity and you know, what I should be doing on a per SIG basis would be useful to me.
So whenever it comes to SIGs, were we looking at it mainly on breakdown from different repositories, or does this also include like chat channels and things like that?
I hadn't thought about chat channels and things like that. I was just thinking about response time on bug trackers, repositories. I mean, a lot of the SIGs, I know that they've automated a lot of their stuff. Builds are happening and people are happily using the outputs, but I don't know. That's a good question.
Yeah, we can figure out how we want to break it down between SIGs, and what are the like measures of activity that are actually important. Are you trying to look at the amount of like comments, pull requests? What is like kind of, how do we want to weight this, and what is actually important to you or to others on comparing across the different SIGs?
I would add mailing lists to that list as well, Sean. I think you can easily do, you know, David mentioned time to response on issues, but I think you can look at time to response on async communications as well. I think if someone raises an issue on a mailing list, it's good to know people are responding to those, right? That's a sign of activity and health. So.
How is the mailing list set up? Or do you know? Or what? It's mailman. Mailman? Okay.
I don't think, I think almost all of our SIGs just use CentOS Devel, so we wouldn't have, does Hyperscale have its own even? So all of the, we wouldn't be able to do mailing list activity per SIG.
Well, some of the SIGs do have mailing lists, but some of the SIGs do have mailing lists, but Hyperscale just didn't bother in the beginning, and I don't know if we would want to, so.
Right, but I think the titles of the mails have tags in, right? They have the square brackets, so you could still isolate.
How like regularly are people using tags? Like, is it, that's the.
We could try. I mean, the goal here is to try, right? So
yes,
we could have a look.
I was just curious to see how much like what is the like community like how often is something that like that being used, just to kind of understand the nature of it.
Well, I think like at least like some kind of fuzzy keyword matching, like the word hyperscale is in the subject or in the body of the first post. It is probably about something from hyperscale or whatever. I know this is pretty common with like automotive, when people talk about automotive or ISA or whatever. Those guys will usually have what they're working on mentioned in it or what they're part of. It's a pretty common pattern, at least in my mental observations. So
Okay.
that sounds like something that can be translated into an analysis framework.
How many SIGs are there?
Like 10 or so?
Yeah, I think
Less?
so.
Yeah. For what is worth, the mailing lists are not high traffic at all. I think for these, the vast majority of comms, in my experience, end up being more on Matrix these days or on side channels. That's actually one challenge that we've raised before, that because of the dual nature where there is the community work that happens in SIGs, but then there's all the work that the RHEL maintainers do in stream. There's no channel to reach the RHEL maintainers. There's no place where people hang out unless you're on Slack, which I'm not because I'm not an employee. So a lot of the conversation ends up being back channels where you ask, oh, who maintains this thing? And then someone tells you, and then you ping the person, and then you figure stuff out. So I think the data you will get from lists is probably going to be fairly skewed. The data you will get from Matrix is probably more accurate for SIG activity, because at least for the SIGs I'm involved in, I think that's a decent proxy for activity. But I think it's fairly scattered around, so mileage may vary.
Yeah, and I think, and I'm reminded of my own interactions in the core of CentOS Stream, that almost every conversation that is productive or useful or gets an outcome is private in a side channel, because there is no public avenue to have these discussions. So that makes that part of the analysis very difficult, because structurally the project doesn't have a public venue of coordination.
Can that change?
Not my call.
It'd be that's a little bit outside the scope of talking about metrics. But if that's the way that, if there is a way of evolving that, if that's a problem that people are seeing, how can we go about solving that? Is there a new matrix channel that needs to be created, or?
We have one. It's just that the people that we need to be in there aren't. So, I think it is useful to consider it in the context of this, that when we think about how do we measure the project health and the community health, the fact that there's a giant sinkhole in the middle that we can't measure is an indication that there's a fundamental flaw that needs to be addressed before we can get into accurate measurement. I'm not, and to be clear, I want to actually have this kind of information because it's super useful, but I just don't know how we're going to have it outside of the externalized SIG work. And when, okay, I'm going to say the quiet part out loud. A lot of the SIGs are not SIGs in the real sense. And so that makes some of it even more skewed and messy.
Yeah, and so that's as we're at the open discussion stage, there's a few questions that are what I would want to aim for once we get to the end of the day, or what are the questions that we actually can answer right now, looking at the conversion for VEs and looking at the activity maybe across the repositories, and then looking at what do we need to set up or work on within this year to maybe have more lofty measurement goals. I really want to make it to where what we aim to have by the end of this year is actually realistic. But right now, I think these are really good conversations to have, because we can talk about what we actually can measure now and what we would want to measure in the future, because usually that takes a little bit of scaffolding.
Sorry, there was somebody passing the mic. That's why I snuck up. Sorry if I jumped in line. The other person go first.
Okay. Hi. There's always been a question in my mind about whether or not there is a correlation between a new contributor's wait time. So they have they're the first time they've ever contributed, and they have to wait a certain amount of time if it's longer or short, and how often or ever they come back.
Yes, this actually goes back to a question that I was planning on asking, and then I got distracted.
Nice.
What is the path for a new contributor?
Right.
What does that look like for CentOS?
Well, I think, like in all open source organizations, it's different for every single contributor. Yes. But that specific one is always interesting to me. If they have to wait a long time, are they less likely to come back? Or is it just random?
That is something that I would be really happy to look into. Because this is something that we see across community of looking at what is the experience for the first-time contributor. Is it something that is, like, if they're not at Red Hat, is that something that where they're automatically not going to be getting an attention at the point that would allow for them to become a consistent contributor, and knowing that what actions can be changed to change that new contributor experience?
So, so my question is sort of an answer to your question, but thoughts for the communities in general. You said, what sort of metrics can we do to get it? And one of the problems, I don't know if it's a problem or a feature of the SIGs, is that they get to say how we communicate, how we do this and how we do that. But maybe it would be nice to say, hey, put some structure in place so that we can say, here's your health. You know, how do you qualify as healthy? You know, if we were to look at you, how do we know if you're alive or dead? Because that is a problem with the SIGs right now, is we don't know, because the way they are set up is set up in a way that they have a lot of independence, and that's a double-edged sword. So, sorry, it wasn't a question, but
it's a thought. No, that's exactly what I want to be like. That's the type of conversation I want to have right now. It gets complicated when we're trying to, how I'm interpreting the SIGs reminds me a lot of, in chaos, we have a lot of different working groups that all behave in completely different fashions. And so trying to measure different groups or trying to compare different groups that have different cadences or different goals, that's when things start to get a little bit complicated. And is the goal to have a equal measurement, or do they have similar behaviors without, or is it to like, I'm saying ethically, but it's not the word that I'm looking for, but to accurately measure and compare, is it that those are different goals and you need to look at different things for each of the SIGs? Like, that would be, I don't know. That would be something that I'd want to think about before trying to measure each one of them like individually in comparison. Because once we start talking about like what is healthy and what is not, you notice that none of my questions or none of the guides of the questions I'm bringing up, a lot of times don't go towards. A lot of times people come to me and they're like, is this community healthy? And I'm like, that's a very difficult and broad question. Let's try to get into a more tangible, small question, something that we can make action from and go from there. The people on my team will know, because many of them do come, and I'm like, nope.
Okay. At the beginning, you said your data analyzers couldn't answer questions, but would tell you what questions to ask. Well, from a scientific statistical view, it's quite a questionable position, let me say. I would rather advise you ask your Oracle of Delphi about what you can ask, but your data analyzers. But maybe you have an innovative statistical theory how to justify this kind of work.
Yeah, I would say that quote was just something more of a thought experiment, because there are some things that we can measure and that can answer questions, but I would say that sometimes that like limits people's scope of what they want to think about, because sometimes it isn't. We're not going to be able to answer why a new contributor isn't staying around, but we can look at the behavior and starting to see, okay, there is a very low amount of people. If they don't get a response rate at this point, then why are we not able to respond to our contributors? It follows up to more questions than a lot of times it provides of what to do. You can start to see what is happening and start to make actions from there. So I guess it's more of just a philosophical.
No, it's not about well, before you can any question or select any questions, you have to clear what is the reliability of your measures, what is the validity of the data. Before you don't have any theory or good positions about that, it's useless to ask questions or to try to look at it. As I said, better go to Week and ask the Oracle of Delphi.
So I think the point of that quote is to say, is to get people to think more deeply about what they want to know, right? Because there's a tendency to think that this is an easy problem to solve and that we can go, we'll just look at these 3 things and it'll be fine, right? And that's clearly not true. You're not wrong to say we can, it's clearly true that we can answer some questions once we know what we're trying to get to. But first we have to get people to think past that first superficial layer, right? I think that's what that quote's getting to, right, Kelly? I would add to that we're on an epicycle system, right? So you're right that you have to think about what are the questions you want to answer and how valid is your data, but you have to constantly ask, do we need to go back to the beginning and refine the question? So you start with a question, right, and maybe some of those very early metrics. Yes, you and I both hate download metrics, right, but that's because you can't ask questions about it. That's where we're getting to, right? If you have download metrics and that goes down, why? There's 100 reasons, right? It's not useful. You can't ask questions about it. And so I think there's an epicycle system where you say, okay, we're going to start with a question, we're going to see what data we can get, can we answer the question? Maybe, and if not, let's go back to the start of the epicycle and refine the question, and let's see what data we have and what questions we might be able to answer with it. And so you keep working until you can get all the way around the circle, right? I think that's the process we're looking at here. But you still need valid statistics in there at some point, yes, and it needs to be correct, and it needs to have valid data, but you also need to work with reality, right? Because we don't have perfect data. So sometimes you have to change the question. Yes, we do. Yes, we do. And I think I would be careful what we say here about looking to see what you can answer. I'm not saying you look at the data itself. That's prejudicing the answer. Look at the column titles you have, right? Can these columns be used to answer that question, not the raw data, right?
You know, as a scientific statistician, I'm quite skeptical. So
we'll keep going.
That reminds me, there's an image of this process that I forgot to put in my slides. That's fun. Anybody else have anything? I don't even know what time it is. We have 3 more minutes. Great. Well, thank you everyone for having such a lively discussion. For the people who brought up questions, even if you don't have time to stick around for the whole lunch, please come see me so I can take some more thorough notes about the ideas that were brought up, and we can see if we can kind of come to the end of this with, this discussion has brought me into 2 places where one side of it is, let's see what tangible questions can we answer this year, and then what is it that we need to be doing within this year to maybe answer some questions that are a little bit more far-reaching of what we can do right now. So that's going to be the goal of the community analysis table for lunch. I hope you'll stop by. Thank you.
Awesome. So just a reminder that we do have the sheet outside for the tables, the lunch tables. You can peek at it, put marks on it, whatever. I'm going to be sitting at a table with Callie, so we have a break now until 11 o'clock. So grab a cup of coffee and join us again at 11. Check, check. Yep. I got lapel, I got handheld. What do you like? You want to hold?
I'll probably get
Yep. Okay. There's also this one here. You guys can have a handheld.
Yeah, I'll just like use
Okay.
this one.
Let me make an announcement in the other room. We'll get started.
Test.
Let me know if I start over these spaces.
Oh yeah, I figured that like while David and I were talking, like his is super distracting.
I'll try not to move. That's fine.
All right. People will trickle in if they hear the microphone. It's 11:01, so I'll stall for 30 seconds here while people get in, but then we'll start our next session. Was the break all right? Was the break too short? I feel like everyone needs longer breaks.
Next time, reverse the time spent. So
Oh yeah, so in the future, speakers will have 15-minute slots and we'll have 30-minute breaks. Is that? Yeah. All right then. We will go ahead and get started. We have two more sessions before lunch. So right now we are going to have I'm not going to read this entire title, but František and Christian
never mind.
will give us a presentation. So please help me welcome František and Christian.
Okay, so hello, I'm František, and I'm joined by Christian from TMT team, and we'll decrypt the PT abbreviation for you, so no worries. So the agenda is then clear. We'll talk about the PT group and what it is, then the relation to CentOS, and what we are working on, what's the plan, and how you can reach out. Okay, so basically, PT stands for Packaging and Testing Experience, so it's a group of projects/teams, I hope you know and love, that are focusing or related to packaging and testing, and also the experience on top of that. So you might wonder why you are talking about this like just group-related stuff that you just got closer together or what, but let's start with the context. So here's the flow of code. That's the environment we work on. So you start with upstream, go with the code through Fedora, CentOS Stream, and to RHEL, right? Basic. And here are the projects under PTE that are kind of related to all of this, interacting on various steps and interacting between each other. And yeah, that's the PTE projects. I envisioned this not only about like this organization change, then these projects got onto one umbrella. And also a few months ago, luckily we have one person, me, that can focus as a PO on all of these projects and have this like high-level overview. But I would like to see it also not only that you work with all these single projects on the way, but we would like to ideally move it to a space or state that there is a one unified view on all of these, one workflow for you. So one task for us is to unify on all of these steps, ideally hide a lot of these changes, and also provide these workflows so you don't need to like interact in multiple steps, but you have like this whatever is manual, so it's like automated. That's the goal of the PT. So what projects are under PT? Let's start with the first one. I hope you know. It's Copper, so it's a RPM build service and also the project management on top of that. And unlike with Koji, that is like tied a lot to the distribution process. Copper allows anyone to create quite easily RPM builds and repositories out of it. So that's like, and it's huge. You see the numbers, so it's quite huge. Another one on the line is Log Detective. Log Detective is actually multiple things tied together on a related topic, and that's the log analysis or build failures. So first part of it is a tool or service that you can provide your failed build log for RPMs, and you get an analysis, AI analysis out of it. Second part is that we are collecting the data from you, so you can give us your log and provide like mark snippets that are relevant, because if you know the RPM logs, there are a lot of unimportant stuff on the way. So you can just pick what's relevant, put comments, and say what should be the fix. And we are building a model out of it, and you can use it as well. So we are trying to get like a really verified data source out of it. And the third part is the service. And for CentOS merge requests, if there is a failed RPM build, you can get this analysis out of it that can hopefully help you better investigate what's going wrong. Third one, Packet. That's the glue or the experience part of the name. So we are trying to provide either CI, so for upstream, and in a month also for Fedora. But there is also this release automation, so we are starting with upstream. And for upstream release, we are opening automatically dist-git PRs with all the changes required for Fedora, CentOS, and SIG-dist-git. And once this is being merged, you can get the Koji build automatically, and then if there is a successful Koji build, you can get a body update. You don't need to use all of that. You can pick only what you need. With the CI approach, there are a couple of pieces, and now you can see how these tools are kind of related, interconnected. Packet aggregates or communicates instead of you with these services, but also chain them. So you can use Copper or Koji for RPM builds, but then you can run testing farm with a VM where these RPMs are already installed. You can also skip this, and there are also other services like a prototype of the image builder. Then you can run static analysis thanks to OpenScan Hub. Siteshwar might be here, and we presented about it last year, so that might be relevant. And also we are working on a log detective integration. And starting point, I forgot to mention, is that it's a GitHub application or a GitLab webhook setup. New thing, Packet team spent like last 6 months working on a prototype. The goal was to spend like 3 months building an agentic workflow so the team can spend rest like the other 3 months maintaining 500 packages. So it was quite interesting experience for that. You can treat it as like a Packet on steroids or something like that. So in that case, we were starting with the Jira tickets and resulting in a merge request that a human reviews. And this was either a backport or rebase. As usual, this is open, so there is a link to the GitHub project. And if you want to learn more about this, Laura made an amazing blog post about this, describing what is the difference between these nice AI demos and running the agentic workflows for real and needing to rely on that. So quite worth reading.
Yep. Okay, my turn. So for TMT, if you're not aware, the TMT is like a way to like manage the tests and the test environments. The goal of it is to make the same environment locally as in the CI, so you can run everything, reproduce everything locally. Another goal is to share and reuse all of the test definitions inside the repository with other packages and so on. The other project is testing farm. The only goal is to run TMT tests. Well, not really. So it also has to provide all the hardware that you're requesting, make it available on the cloud, and to display the results. So where are we in respect to CentOS? Well, all of the components are there. Packet can connect to CentOS stream, couple can build it, TMT and testing farm can test it, and so on. We already have it working on Apple. Some tests are not working, but we're still working on it. So what's left is to glue all of this together. And for this, we really need your user experience. So what are the workflows that you're using, particularly in the SIG, because it seems like every SIG has a different kind of workflow. And how can we help? How can we do these kind of automations, and what kind of things we are missing? Yeah, and now for the roadmap.
Yes, so let's take a look what the teams are working on or what's ahead. So what I've already mentioned is that Packet will be in a month or so a default solution for Fedora dist-git PRs, and it will replace the Fedora CI and also Zool-based solution. The reason why we've done this is because, as I mentioned, we are opening a lot of dist-git pull requests and we want to rely on them. So we said, yeah, we are doing it for upstream, so let's help. So that's the reason. I hope we will provide a solution that is reliable. We also are working on these checks, as Christian will be mentioning later on.
And also the scratch builds are no longer timing out.
Ah, yeah. Oh, that's good. Yeah. Okay. What about the agentic workflows? We finished the pilot, and we are now rethinking how to do it like a long term, more sustainably. If and how it makes sense to maybe use Packet inside of these, or maybe bring this AI approach to Packet. So still discussions if what makes sense. Next one, yeah, with the log detective, I've mentioned we have analysis for the CentOS MRs, but the team is working currently on getting them to Fedora dist-git PRs, because that's the place where a lot of builds actually fail, and much more than on CentOS. So this is, we think, the place where this might be helpful. And since we are now closer, instead of creating custom Git integration, we would like to get it through Packet. So Packet will be the Git integration, but under the hood, log detective will take care of the log annotation. Another log detective related change is that on the left there is the previous approach. There was some heuristic going on that we get a few snippets that we found relevant, then analyze every single one of them, and then summarize. Newly, we would like to make it both quicker and more intelligent, so we would like to switch to an agentic mode. So we would provide these snippets and some other resources, like about the project itself, diff, also packaging guidelines, and ideally also the annotated examples. I've shown previously that we are gathering the data. Agent can pick what it needs and found relevant, because a lot of snippets currently are not so relevant, and it can provide a summary. So that's the next step we would like to do. Also technicality, but I think worth mentioning is that Copper team spent a couple of months switching from their own solution for storing artifact storage to a pulp-based solution. So huge thanks also for the pulp team for making it possible. And so implementation is done, and now is the tough part to get all these terabytes and insane number of RPMs to pulp for real. So that's what's ahead.
Okay, for TMT and testing farm, we're moving the artifact installation away from the testing farm and to TMT. This should help you reproduce the testing farm environment more freely. So if you have a Koji Scratch build, you can just add it in there, and then it will create the repo, and it will make sure that the package that you want to install is coming from that repo. One change that we're going to have to make is we're no longer going to install all of the packages from that repo by default, and instead you have to specify which package you need to install. That did create like a lot of problems in the past, and we want to make that change. There will be a change proposal on Fedora as soon as everything is settled. This is now currently in technical preview, so you can try it out locally. Yeah, and Franciszek mentioned about Fedora CI and our plans to make a shared test. So the idea is to have only one repo with all of the tests that are being run by Fedora CI. So if you want to like add any kind of test, then you can just like add another example of this, and then it will run on your. This should make it like very easy to contribute, like it's only one repo, and hopefully it could also be independent of the infrastructure, so we can also run it on Packet, on upstream, and whatever. One question that we're currently struggling with is like where exactly to put this kind of repo, and also like the inner repos like RPM inspect test and RPM lint, where they should live. For testing farm, again, want to support the multi-host test. So the multi-host support is already in TMT, like you can already do it locally. The thing is that Testifier needs to like manage all of these guests. So already you can do it from the CLI of testing farm, but we want to also support it running directly within Packet and Fedora CI. And lastly, bootc support. So the thing that we're struggling over here is to make sure that everything that you run in the prepare, like the installations, the script, and even Ansible, has to be persistent after a reboot. Right now, we're currently only supporting the package installations, but we're working on the other parts. Yeah, and that's about all of the roadmap that we have now. And again, what we really need right now is feedback from you, how you're using it, and what are your pain points, what do we need to focus on. You can find us over here on all of the GitHubs. We have some metrics channels for each project, and newly, we also have a Fedora CI tag for discussions. Yeah.
I hope we don't need to entertain.
Hi. What can we do to help you get bootc support? That is something that we're using in automotive SIG. That is something we absolutely want to be a first-class citizen. We want bootc to be the way that we deploy things for automotive. How can we make sure that you're getting what you need to make that work?
So it depends on what exactly you need supported. So if you don't need support for reboot, if
we do.
Okay, then we're gonna have to work. It's mostly on our side because it's mostly on the TMT infrastructure to like make sure we change the logic of how we call stuff.
We're also migrating all of our demos to TMT so that we can run the demos from TMT, which is fantastic for us. We love you guys.
Yeah.
But yes, we want that to work in bootc just as well as a first-class citizen as package mode.
Yeah, we'll try to like, as soon as we have the stuff ready for the prepare steps, we'll try to like give some kind of other announcement and like make sure you're ready and you can give like some early feedback.
Yeah, and probably that might be something else, so we can maybe then follow up if you encounter something else.
So, I noticed that you mentioned, like, as part of your diagrams, you talked about upstream sources being GitHub and GitLab, but like it's also started to become a little bit more common to see others like Forjo, GitT, and other places like that. Specifically, in the Buddies of Budgie, which is an upstream Linux desktop project that I'm part of, we're talking about having continuous integration and delivery as part of our development process of Budgie 11. And for that, we would like to be able to plug this kind of stuff into our Forjo instance, and we want to be able to do things like build the set of packages with the dependencies resolved, and then take that as an input to then build an image using Kiwi, and then produce that image that we can give to testers and our open collective backers as early access stuff. So like a lot of what you were showing is basically like, hey, I may not have to reinvent all the bloody wheels to get this done. What can I do to help you to make this a thing that we can have?
So if I get it correctly, you just want something like that, but for a different GitForce, this upstream-like approach.
Yeah.
The thing is that like there are two ways. One is we need to get information from the GitForce, so some kind of notification that needs to be put to the package service component, and yeah, either some webhook based or messaging bus. Yeah, that's one part. Second part is like how we communicate back to the GitForce. We have an Ogre Python library for that tries to be a unified API for all the GitForges. So if you implement this implementation into this library, automatically, hopefully, package will just, we are trying to unify that, but GitLab, Azure, and other stuff that doesn't help us a lot. But yeah, ideally, like there is a line, so we do, if you provide this implementation, it will just work.
Okay.
So yeah, we can probably.
Yeah, let's talk after this a little bit.
Yeah.
But like the other bit is like you have this image build thing, and you talk to the guy about the Bootsy, and then there's image builder. It'd be nice if also we could have something along the lines of being able to support Kiwi as an image thing.
Yeah, we discussed that multiple times. If anyone is interested in helping with that,
I'm happy to help. I just don't know what I'm supposed to be doing.
Yeah, with image builder we had this in prototype state for a lot of time because after all, when we finished that, not many people wanted to use it, so we just stopped the development because no one cared. So because we thought that we can focus on other stuff.
Right.
So yeah, but if we know that there are a lot of people interested in this, yeah, we can consider. That's the usual rule, that based on demand.
Yeah, I mean, I feel like there's a lot of demand, at least between like, for example, Fedora Sahi and mainline Fedora and CentOS Hyperscale and Alt Images. We're all using the Kiwi tooling for stuff. So at least from a distribution context, there's that. But like Buddies of Budgie wants to reuse the Fedora definitions for Fedora Budgie to spin up these new images as they're developed.
Maybe to that specific image building setup, the nice thing with image builder is that it understands RPMs.
Yes.
And it takes care of the infra for us, because there are a lot of either tools that understands RPMs, but we would need to do the runners for us, or vice versa. So that fits like both these check lines for us.
Yeah, well, let's talk about it a little bit, but I'm glad to hear at least you're open to having this feature.
Done behind.
So I have a question about, I have many questions about the agentic stuff. Mostly, so are you tied to specific models? Are you tied to specific Red Hat workflows? And
it's actually like we are trying to not be tied to a specific model and be like agnostic, and so we can maybe switch. And it's running currently the BAI framework. That's how it's built on, and a lot of details are under on the blog post. But regarding the workflows, there are a couple of. It's split in multiple separate agents. One is responsible for triaging, one for backport, one for rebase. So you can take a look if probably how it's defined. Yeah, a lot of stuff might be like CentOS stream tied, but something can be maybe excluded or so. Yeah, okay. And there is also like a few other people work on like post-merge stuff, like this QE related work. So that's also somehow.
Okay, so is it mostly custom code, or did you experiment with something like skills from Anthropic, where you just have a generic agent and you instruct and you give it more or less just instructions how to do things?
It's like an agent that has a lot of these deterministic tools, so it's secure, and also we don't need to like let the generic model to learn how spec files work. We can probably better do some deterministic way, or so it's like we started with a very generic thing and then started to like putting the deterministic stuff into that, so we can somehow rely on that.
Okay, and then how well does it work?
Quite, like depends. Like it depends on the type of ask, and we also labeled the situation when it didn't occur like, or finish in a good sense, and there is. So we are analyzing that. So yeah, very depends. What I like compared to Packit is that it can learn from the fault if there is something, either a temporary error or some conflict on spec file, it can like recover from these faults. So that's what I would like to see on Packit side, for example, that I'm amazed. But sometimes, yeah, it's AI, so expect it, like, yeah. And yeah, you really need to do some infrastructure on top, like behind. Yeah, it's not like just running a demo.
And don't forget to review whatever it creates.
Yeah.
Of course. Okay, thanks.
That's it. Thanks.
All right, we will get our next speaker set up. I'll take it. Are you good with that mic? Do you want a lapel? Do you want one of these?
I think we will be okay with this.
All right, we've got one more before the break. Joseph, who has been my impromptu mic runner, so I'm going to have to run my own mic now. So are you ready to go?
I'm ready to go.
Okay, so please help me welcome Joseph Marrero to talk about Bootsy.
Okay, so I'm going to talk a little bit about Bootsy and how you can manage your CentOS deployments the same way you're managing your application containers. First of all, my name is Joseph Marrero. I work for Red Hat. I'm part of the Bootsy team. Part of my responsibilities are maintaining the CentOS packages for Bootsy, RPMOS3, OS3, and help with the development upstream and the development of the images too. So what is Bootsy? So Bootsy is a tool that allows you to define and ship as OCI containers your whole OS. It lets you do deployments, and if that deployment doesn't go well, you can roll back. So you install a new application, new configuration, it doesn't look like what you wanted. You can just do a Bootsy rollback, reboot, and you'll be back into a known good state. There's a capability to having logical bound application images. So your HTTPD, Grafana, any type of application containers that you might have. You can also handle the life cycle of them with Bootsy. So we'll keep track of the tags that you're following, and if you do those deployments and it doesn't work, you roll back, you get the previous version of those applications too. We have integration with Podman and other compatible runtimes, so you should be able to build the container image the same way that you have been building container image all this time. If you're building with Docker, you can still build with Docker. If you're building with Podman, you can build with Podman. If you're doing it in a cluster, you can build your container files the same way that you have normally do it. You are able to use Bootsy OSs or base images deployments in Kubernetes or standalone in your own home labs. Even your desktop, this machine that I have right here, is deployed using Bootsy, so this is a Bootsy deployment. And we recently became a CNCF sandbox project as of last year. And so, quick question, who here knows how to build a container?
we're in good company. So if you know how to build a container, an application container, you know how to build a Bootsy container. The same way that you're doing it today, you just need to change the base image. So what does that look like? So here, we're using HereDoc, so it goes into a single layer. So it's a single run command here for this container file, but if you have multiple run commands, pretty standard process for the container image, you just have more layers. The big difference here is the from line, which in this case is a CentOS Bootsy image. In order to do deployments with Bootsy, you'll need a Bootsy image. What's different about this image is includes the kernel, includes the bootloader and in RAMFS in the base images, which will allow you to boot it. So the normal application containers does not have a kernel, and this is a big differentiator with the Bootsy image. We do a lot of different processing of the scripts and stuff like that when we build the base images to make sure that the applications get installed correctly and stuff like that. But everything is open source. Everything is upstream. So if you want to build a base image from scratch, you can. Many of the community have already started doing stuff like that. But yeah, so this is an actual example that you can test today. If you copy and paste this, you will be able to take CentOS Bootsy and just replace the regular kernel with kernel RT. And the only thing here that is not required, but it's a good thing to have, it's the Bootsy container lint that will tell you if you have more than one kernel, which is not supported, you need to have just one, so it will error out, or tell you if there's any problems with the file system that we will catch during the build time. So CentOS Bootsy is CentOS. It's the same content that comes from the same repo on any of the other images. So if it's available in the repos, you can build an image with it. The difference between a package mode system, which is, you're managing with DNF, DNF install, DNF update. If you're updating the distribution, you're doing RPM upgrade, and it's calling into the RPM repositories. You download those RPMs one by one, install it by one by one, etc. The difference here with image mode or Bootsy systems is that instead of handling that with RPMs, all that building with the RPMs passes to the build side, and when you're actually installing it, you're talking to a container registry. You're building it with container tools like Podman instead of Image Builder, for example. You're using Bootsy to manage your deployments and your updates and rollbacks instead of DNF. And instead of having RPM repository, you have a container registry. So Bootsy is a general purpose OS. So this is not only for running containers. You can do whatever you want in these images and deploy it, and you can use it for your desktop needs. You can use it in bare metal, in the VM, in cloud, in edge, whatever your needs are, you can adapt Bootsy for. There's a big difference on how you manage the system, which is normally if we want to alter our systems in package mode, we just open a terminal and install a new package, and the package is there forever, right? If you want to run a config, you gain admin access and change something, and that's how you configure your system. This is a change of mindset of moving that workflow into the build side. That way you have an image that is the source of truth for all your deployments. So you build once, and you can deploy once, or you can deploy 1,000 times. It's up to you. So how does that look? You have an administrator that writes a Docker file, a container file, does a Podman build. They can, that Docker file has a Bootsy base image and all your applications and configuration in the different layers. You build that, you get your custom image, you push it to a container registry just like you do with your application containers. So if you're using Docker Hub, you can push Docker Hub. If you're using Quay, you can push to Quay, GitHub packages too. Because this is a container, it's an OCI container, you can also have testing automatically happen as part of your pipelines, or just spinning out that container and checking, does it have the correct RPMs installed, does it have the correct configuration. And you can also spin out a VM as part of those CI pipelines and actually test end-to-end with the same content. Then when you're ready, you have blessed those images with the tag that says it's production. You can do a bootc install into whatever system you need to do a bootc install. Okay, so I have a little demo. Something pretty cool about bootc is that even the installation process can run from the container. So you don't need to have bootc installed in your system. And we have created a package called system reinstall bootc that just basically gets you podman and calls the bootc command with the default flags to replace a system that is package mode and convert it into a bootc system. So I got a couple. So I just recently deployed a droplet in DigitalOcean, and this is just a standard droplet. Like if I leave it running, I'll pay $16 a month. Nothing special in this thing. I selected CentOS Stream 10 as the OS, and I just spin it up, and this is, I just SSH into it. You can see just a standard CentOS Stream 10 deployment. Let's confirm we're in package mode and just install strace. So it's installing, it installed. If I want to write to Etsy, I can. This is just the standard CentOS Stream 10 that you all know and love. But now, part of the repos, we have a new package called system reinstall bootc. And you'll see pulse podman, some other dependent packages. And once this is installed, I can convert this system into a bootc system. So part of the title of the presentation is managing it, how you are managing your application containers. And this is a very basic setup. I know that many of you have more complex setups, beautiful things that are testing many things, very cool application containers. But here we have an HTTPD example that has an index.html that is very complex, very colorful, and says, hello, CentOS Connect. And that's just a container. And nothing special about it. You see the base image there is just CentOS Stream 9. And I'm installing HTTPD. I have a GitHub action that builds this for me daily. And once this is built, it gets pushed into the packages section. So I have here a container that I can just run, and it will have HTTPD. So what I did for the demo is that I added a new folder here called container, with another container file that uses the CentOS Stream 10 bootc image, install Cloud Init because DigitalOcean needs it to be able to run those VMs in the system, and just enables the Cloud Init target, and that's it. That's what we have in this build. This was built already by the GitHub action. You can see that this one was automatically created, and it just was built like a standard container with a build action. You can see it's just installing Cloud Init and setting up that systemd service. So I'm going to take that container file now, that container image that I built and pushed. I'm going to grab the image from the repository. I'm going to bring it to this system that just installed system reinstall bootc. I'm going to do system bootc and paste my respec. And when I do this, it's going to download the container image. Then it's going to ask me if I want to use the SSH keys that I have so I can log in after the reboot. If you don't do this, you might not be able to log in. And once that is done, I will do an actual deployment and replace my system. So it means that to install a bootc system, you don't need to necessarily go and create a disk image or to create a USB drive and plug it in, or create an AMI image to deploy into AWS. You just deploy a CentOS Stream system in the cloud, and your system reinstall bootc with your newly built container image, and you'll have a new bootc system running. This will take maybe 30 seconds more. We have, we have a bunch of examples in the repositories. We have examples on running Ansible as part of the builds, running in AWS, installing Docker, FIPS, simple things like HTTPD, FDO, how to inject KARGs, running kernel RT, and things like that. So if there's a special use case that you think you may not be able to use with bootc, there's a good chance we'll have an example. If not, please open an issue for us, explain what you're trying to do that you can't, and we'll gladly try to create an example for you. So we should have, asking me if I want to use those SSH keys. I say yes. It's telling me that it's going to reinstall the system, and it's going to get all the content from my system and put it under /sysroot. So it's not wiping the whole file system. We're just moving it to sysroot. So if you have stuff that you want to copy after the install, you can do that, like config files and things like that. So that has downloaded the container image that I built with a GitHub action, and it's doing the deployment. And while that happens, and we finish the deployment, I can go ahead and modify my container image. So I showed you an application container before, and I talked to you about the logical bound images, something that we can do here. I already prepped and configured this for logical bound images, and I'm basically enabling here a Podman quadlet that will start that HTTPD container, and will track its deployment with bootc. So after the install is done, I'll do a bootc upgrade, and it will know, oh, there's a new version of the image. It will download the new version of the image. And once that download is done, it will say, oh, I have a container image that I also need to pull, and it will do that for me too. So I think we have successfully done the install. Now we have to pray to the demo gods that when it reboots, I can SSH in again. Let's see if that happens. It'll take a minute or so. Meanwhile, yeah. So meanwhile, we're just building the containers again with the simple change that I did. And this is building both my HTTPD container and the host image. So, yep, it's there, complaining about the SSH key known host, but I trust it, so we just logged in. And so a big difference now is if I try to do the same thing, right? Well, if I type it correctly, and just say, go for it, it will try to install strace, but it will tell me, no, you're in an image mode system, you need to either build or create an overlay, or you pass Terrancy and we'll create an overlay that lets you install strace, but when you reboot, strace goes away. So we're already in a bootc system. How do we confirm that we do bootc status? And now you can see that it's the booted image comes from my GitHub repository, and it's tracking latest. So what that means is that we successfully turn a package mode system into an image mode system with a single command. We just build a system and push it to a registry, copied the ref spec, and did system reinstall bootc, reboot it, and we got an image mode system. Now, the build just finished, so imagine you have to add new packages, new configurations. You want to make sure that everything is pristine, and you keep iterating in your Docker file. Every time you do a build and you want to test something, you can just do bootc upgrade, and it will download what is the diff between that original image and what you have in the new image. In this case, we're talking about 256 megabytes. Thankfully, we're going through the droplet, so hopefully this goes fairly quick. And once that happens, we'll reboot again, and we should have the logical bound image attached to this deployment. Maybe while this downloads, any questions?
Hi, so I have a question. When you have a system like that with a bounded other container, can you independently update HTTPD without like upgrading whole system and rebooting, or is it like if you wanted to update HTTPD once this command finishes, like do you need a reboot every time, or does this container can be updated independently?
So this specific container is tied to the bootc deployment, so it will be updated with bootc, but this doesn't mean that you need to have logical bound images to run any other containers. You can run containers with Podman the same way that you would normally do it, and you can update them at any speed that you need without needing to be rebooting all the time.
Okay.
This is made for some use case where someone wants to tie the life cycle of the containers to the host, and everything will be together in a simple package without having to put them all in the same container image. In the past, people will just do like Podman pool inside the container build, so they will have this huge image with HTTPD or an LLM model with the OS, and we will end up with a container image with 15, 20 gigs, and we don't want that, right? So we are enabling this behavior that you track both together. But if you don't want it, you just use Podman normally.
Okay, cool.
Are there any limitations or requirements for the base system that after that you want to upgrade to the bootc image?
For the basic, you mean in hardware capabilities, or you mean just
you have started with the regular system,
yeah,
and then you have upgraded into a bootc.
Yeah. So
into the bootc. So I'm asking about the original operating system, if it has some limitations or requirements on it.
It will be the same limitations as the host or the initial system that you are starting with. If you are going, for example, from package mode in CentOS Stream, you will not have Btrfs. If you try to like bootc switch from Fedora, your system is Btrfs, and you try to go to CentOS Stream, it would not work. But generally, if you have Podman and you're going from the same type of kernel to the other image, you should be fine. Yes, if the image that you built if the custom image that you created has the Btrfs module, it should work too.
Related question, does it support dual boot?
What like with the
Yeah, if I have a Windows partition as well, and I try to do system reinstall boot C, will it clobber it? Will it still work?
It will not. It will. It will install it on bootloader. So I don't know all the details about running Windows and dual boot with it, but I can try getting back to you about that.
Sadly, I still need Windows for one 3D program.
I understand that.
What's the status for other distros?
So for other distributions, so right now we have CentOS Stream, Fedora, and RHEL that our team is responsible of. There's a lot of community involvement. There's this big community called Universal Blue. They're Fedora related, so it's also in the Fedora world. And they have a bunch of images. All of them are using Bootsy. But there's this new team, they call themselves the Boot Crew, and they created base images for Arch, Ubuntu, SteamOS, GNOME-OS, OpenSUSE, and Debian. So there's a lot of community involvement and excitement around this. So if you want to use one of these ones, they're in active development, and you can reach out to them if there's anything that doesn't work. But there's a lot of movement.
Follow up quickly. Can I have multiple distros and boot from Bootsy and switch? I want to test this, I want to test that, or is it out of scope?
I haven't tested it, but you can switch from Fedora to CentOS, from CentOS to CentOS and to RHEL. So we hope that people can just switch to the other distributions and just test. If it doesn't work, it's an issue that we need to fix.
Are you aware of any RPM native way how to build Bootsy containers, or it's complete anti-pattern? Because why I'm asking is that we are providing a CI and need to do the builds for the users and put like one-time RPMs on the fly. So templating the Docker files is not nice.
I didn't get the first part, which
like
is
if there is any like RPM native way how to build Bootsy containers. Or I know about some efforts on that front, but curious, like, what do you know?
So in the container file itself, you're using the RPMs to build those containers. So we don't have a solution at the moment where you can run an RPM command or a DNF command that will generate a container for you. But if you want to use RPM content, you will do it the same way that you're building any application container. Which is using DNF inside your container file. I don't know if that's... Okay, so you can in Bootsy systems, like if I pass DNF install strace transient. I can do this. It will install the application in an overlay. So if I want to use strace now, I can use strace. It's there. So I can use strace how I normally would, but at the moment I reboot, it goes away. So it doesn't stay, it doesn't persist. But if you're a developer, I use this all the time if I have to do a quick check, or there's another tool that we have called Bootsy USR overlay. We'll create a USR overlay, and then I can just build a Go app and put in USR bin, for example. But once I reboot, it goes away. So there's ways to work around the limitation of not being able to move files in USR after you have deployed, but they are temporary.
Thanks. I mean more on a build time. Like I have there is a pull request opened. I create a RPM in Cooper, and then I want to have a Bootsy image containing this RPM for the user to use. So many of that's the use case. Like I can template the Docker file, put it there, but it's like if you need to like dynamically change the content, it's not so handy.
Yeah, we probably can talk about it after the session. I think, we have examples using copper and custom RPMs and stuff like that. So I can get back to you.
So I had another question about you demoed how to install Bootsy itself. How do you manage the image, the host? Because in OpenShift, if you have a pod, you mount secrets and so on. It's part of Kubernetes, but how do you manage Bootsy? Do you still use classical tools like configuration management tool like Puppet or Ansible inside? Or because you don't want to build one image per host you manage that has specific credential for that machine, right? So is there some part of the Bootsy image that are like a normal container still writable and that persists on reboot? Otherwise, how do you manage a fleet of Bootsy machine?
So for configuration files and stuff that you need to change per machine that you don't want to cook in the image, you still can use stuff like Ignition, or you can use stuff like Cloud Init, which I'm using here with the droplet in DigitalOcean. You can use Ansible if it's stuff that goes into Etsy. Etsy is writable, so anything after the first boot, you can just run Ansible against it, configure services and things like that, or set up users. Something that we encourage a lot, and it's a pattern around our docs, is if it's something that you can configure with a systemd unit that runs on first boot, that can query like a DNS or see what machine I am and gets that information and reconfigures itself. That's a type of pattern that we think it's useful too if you want to cook everything into the image but not the secrets, right? It pings something and then configures itself based on that. But we don't have, we are very inopinionated. We don't have opinions in how you would do this stuff. If you want to use Ansible, shell scripts, you want to use systemd units, it's up to each person to deploy what is better for them.
I had a question. I'm kind of asking this question on behalf of Jeff Ligon because he brought it up over a beer last night. I don't know if he's in the room. Oh, he's here. So I use Bootsy quite a bit to, it's nice to be able to define my environment and build it as a container to have some level of confidence that, my random version of Fedora Kinroid with all my random packages sprinkled on top from Docker repos, Coper repos works. But some of these machines are throwaway machines, right? I don't really care about them being immutable so much, but I have an opinionated way of why I'd like my machine to be set up on boot. And I'm a hacker, so I want to be able to change stuff. Have people looked into, you define your Bootsy container file and, it's deployed in a mutable way where you can change everything from then on, basically? You don't really care about things being frozen.
Yeah, I think this is something that people ask about, maybe once a month or someone reach out about this idea. There's nothing technically that will prevent us to support that in the future. It's not just part of the roadmap at the moment, it's part of what we're focusing on. Part of the big things that we're trying to deliver with Bootsy now, it's the whole image sealing story and the security aspect of making sure that what you put in the image, once you sign it, you make sure that it gets into the hosts and no one can, adulterate the content, right?
No, I agree. And obviously that's important for production machines. But when you're a developer, you kind of want to change things quickly, and you don't care. Sometimes it's a throwaway machine like a Raspberry Pi, and you don't really care.
I don't know if there's an upstream issue. One of the ideas that was floated was that we would help you do that initial install. and then you're on your own, so you keep doing DNF
Yeah,
update
that's kind of
to
what
do the system.
I think
So
makes sense.
this is something that is in our radar, and I cannot commit to or team to do anything, but it's on our radar, and the more people ask for it, the most likely it gets into a roadmap.
I'll repeat it. So it was something that came up very early on when Bootsy was first being discussed in Fedora, and I know I brought it up as like, it would be super interesting if we could do this, is being able to have a mechanism to do this where we can transfer it very quickly, and then after the fact, we don't actually care that it's a Bootsy type system. It just goes back to being a regular quote unquote package mode. And this makes the image versus package mode denomination a little bit more true than it currently is. Because right now, like, they don't have commonalities and workflows. There's no real switchable facility to make them modes. So being able to make them more modal is actually, I think, something that would make it extremely useful and interesting for a lot of people, because then people can look at it as, hey, I want to make this initial provisioning process, initial distribution, and I don't actually care one way or the other whether some systems may make sense one way, some systems may make sense the other way, but that can be decided at install time rather than, being locked into it just because you wanted to use one way of preparing your initial provisioning.
Yeah, I agree with you. I think making it easy to switch between modes will be a killer feature. But if you all care really much about this, I encourage you to go into the GitHub issues and open them.
Back to the image build topic, these are OCI containers at the end of the day, right?
They are.
So you should be able to build this with anything that can spit out an OCI container.
Yes.
So it should work if you build this with something like Kiwi, for example. You could have a pipeline in Koji or whatever that already knows how to build images with Kiwi that spits this out, and you could have that tied into RPM build workflows and things like that.
Correct. If for some reason it doesn't work, it's a bug somewhere, either in Bootsy or maybe how it's being built. So, anywhere you're building your containers, you should be able to just use.
Cool. Thanks for clarifying.
Is there an option to use container repositories that require authentication?
Yes.
And how will you pass the authentication information into the
You can
machine?
do it at first boot with Cloud Init or Ignition or with a script or systemd units, stuff like that.
So basically you need the underlying system to have the, sorry, not the underlying, the image to have the credentials in it.
Oh,
and
sorry,
then
sorry.
you
From the install command, it will give you an option to pass the key. Yeah.
Awesome.
Hey, so the question that Eric so nicely tried to ask on my behalf, I've asked it so many times, I think I can shorten it down to make it much more crisp, which is, can we deliver package mode via a Bootsy mechanism so that when it flips over to that thing that's been delivered, you just have a package mode system? And that's what you said, yes, absolutely. And it was because I promised you that 2 years ago at DevConf in a Fedora infrastructure call. Yes, yes. So I'm still pursuing that, but right now there's nothing about any of my customers that are asking for it other than you. So I want to give you that, but they're working on it, not me, right? So I'm trying. I'm advocating on your behalf, yes. I want you on the Bootsy boat so that we can continue to do that. Because yes, anything that can build an OCI image can build a Bootsy image, right? And that becomes as powerful as Joseph can show us with just, okay, so there's an upgrade available. So you upgrade the image, and yes, it's decoupled from the application containers that are running on top of it, or it could be coupled if you want to. If you want to put the actual container image of the application container into the Bootsy image, we do that in automotive all the time. It's not a requirement, but it is a nice to have if you know you're just going to have one initial bootstrap of that image onto the disk, right? So I love this. I want it to succeed. I want it to help everybody, and I want it to be used in every distribution because it just makes sense to me coming from a more container native world. but I absolutely don't want to force the Neil Gompas of the world to do everything I'm doing. And as OS tree goes further and further away, hopefully we can help build a more wonderful Bootsy future together, yes.
Yeah. Let's do 2 more questions and then we'll finish the demo, or?
So if I want to give, let's say, the desktop install, like the one you have, and I want just a tiny bit of flexibility for my users, can I add, let's say, Flatpak to the image? And then will the Flatpak or Snap packages installed by the users remain on boot, or will they all be gone like the one that you showed with the DNF?
So you can today use Flatpaks, and it will persist after reboots. And you can use Snap too. We sat down and we tested Snap, and it just works. So you just need to install snapd as part of your container file. And once you reboot and you have enabled the service, any Snap that you install, it will survive the reboots.
Yes, so I know with Bootsy you obviously can stage an image and roll back from it, but there's some stuff on a system which you can't stage, like the grub bootloader, potentially firmware updates. How does kind of Bootsy handle updating grub, updating potential like microcode on the CPU or whatever like that?
So Bootsy on purpose does not deal with your bootloader. That's dealt with a bootupd, which is another tool that we use to update the bootloaders. And it's part of the ecosystem, so you get bootupd with every Bootsy deployment, and you just call bootupd update, I think is the command, and it will update the bootloader for you. Firmware, you still will use FWD or FW, I'm going to kill, yeah. So that still works. There's nothing special because that's not happening itself in the user space, right? So you keep using the tools that you are accustomed to for the framework, and for bootloader it will be bootupd. So we have installed, we installed the system, we rebooted, and you can see when I pull the new update, it has a new line here that says that it found a bound image. It downloaded my HTTPD. But if I try to run it here and try to do like localhost, there's nothing served there, right? So let me reboot again. And let's try to go into that stage deployment. So when you reboot a Bootsy system, that stage deployment gets finalized, and it gets ready, the bootloader gets updated, and once we reboot, we'll have the new deployment. And hopefully we also have our HTTPD container running. Okay. Okay. That's because I haven't cleaned up the sysroot with the old deployment. Nothing is broken, I assure you. And what happens now if I do curl localhost? Ooh, I need to pass this. So now we have an actual HTTPD server running, and a beautiful HTML that says, hello, CentOS Connect. So we have successfully done a deployment. We have pulled an updated image that pulls a bound image, a bound application container, and once you're running, it automatically starts your container and it's served. I think that's the demo. I have a couple more slides. You know, I talked about this a little bit already, which is you can use this LBIs with AI and ML stacks, for example, so you can set up bound images for a lot of LLMs. You can use this for your desktop, your VM. You define your application and your host, and you deploy it. Edge devices, you just build once, push it in a registry, and deploy it to 1,000 devices if you need to. And you can use this, for example, CoreOS is based on Bootsy today. It can be just a standalone host where you just are running containers. And I talked about this already and I showed it to you all, which is system reinstall bootc. Something that is coming is ComposeFS. Right now we are, the default path uses OS3, but we're gaining the default, we're gaining a different backend, which is the ComposeFS backend, that will also enable a lot of things like the DM Verity and allow you to make sure that your system is not adulterated, and if someone touches the system, it won't boot. We have docs, or Fedora and CentOS Stream docs are together, so if you want to see our base images, you can go here and you'll have a list of some of our base images. Like I said, there's a lot of movement in the community too. Something that we would love is for more companies, more upstreams to join us in the bootc upstream to help us develop. If you already are using bootc or you are giving bootc to your customers, we have a section in our GitHub repository in bootc dev bootc, that is the adopters. Please go there and create a pull request for us. If you are an adopter of bootc or your upstream or your company is a adopter of bootc, please go here and make a pull request against us. You know, we are a CNCF sandbox project, part of the process of becoming an incubating project and becoming an outright CNCF project is showing that people are adopting this and enjoying it. So please, any help with contributing to the upstream, to the Fedora and CentOS communities, it will be greatly appreciated. And I think I have 4 more minutes. If there's any other more questions.
So how generic is your approach, how you dump the contents of the OCI image to disk, and how does it work exactly? So does it rely on just ComposeFS, or I think I faintly recall that at some point it was also using OS3?
So currently we have both OS3 and ComposeFS. It is opinionated, so everything under var is writable, and etc it's writable, and it gets a 3-way merge when you are doing a new deployment. It sounds very complex, the 3-way merge. The only thing that means is that we take the content from the image, and anything that you touched that it wasn't in the image, we won't touch it anymore. So if you have a Kerberos config that you touched, and you update it in the image, you'll not get the update from the image because you touched the file. So once you touch a file in etc, you own the file and it's not coming from the image. But you can reset that by resyncing with the content in the image, which also put in the disk. We have options to have a transient etc that any configuration in etc, when you reboot, it gets wiped and you get exactly the content from etc that came from the image. That means that you will need to bake mechanism in the image to get reconfigured in every boot. But yeah, right now, if you have used OS3, it's still using the OS3 path for how opinionated it is with the file system.
So I'm wondering about this from a cloud perspective, and one of the things in Amazon EC2 is the ability to do attestation on image creation. Is this something that might be possible to leverage using, say, Nitro Enclave?
I don't know what that tool is.
Okay, yeah.
But there's a lot of
yeah.
So there's a lot of work happening in secure computing and to make sure that we can use TPM devices and stuff like that. So that's coming. There's a lot of stuff that's already merged, and there's a lot of stuff that is in progress, but it's part of the roadmap, and it's, you know, I think there's a lot of issues upstream about it. that, you can feel free to reach out and I'll find them for you.
Quick question. How would you back up your ETC on the container?
Back up?
Yeah, so for example, like on normal Podman, you would mount your ETC from somewhere else. Like how would you do it within the bootc?
You mean like mounting etc from another source?
Or just backing up, like what
Well,
would be?
you can, it's just files in the file system, so you can still just rsync, use rsync with etc. Once it's deployed in your system, you have full access to it to copy the content anywhere you want.
Yeah, but for example, if you want to recreate it again,
okay,
you would have to like mount it first and then boot up the bootc.
So if you want to modify the pattern, is you go and modify the etc in the container file. So, for example, in this laptop, my container file has my Kerberos config, and if tomorrow that changes, I go and change the Kerberos config in the container file. I rebuild and I do bootc upgrade, and I get the new update to those etc files. If there's stuff that you don't want baked into the image, then you'll have to manage yourself that with, rsync probably. Thank you so much.
So do you need sudo to build a new container image?
No.
So you can build this with regular user Podman, and you don't need sudo to recreate the entire image?
No. So especially if you're just layering, you can do this without any privileges. So if you use the CentOS stream base image and you're just adding stuff to that, adding packages and stuff like that, you can just do Podman build like this, and it will just build. And there's no sudo, there's nothing special here. And that container file is what it was in the demo, which is actually replacing the kernel. I need to go check the docs. I don't remember. But we got people building them in CI, and we have the documentation even to create a scratch, base image from scratch, and that does need some privileges. That cannot be done in a unprivileged container. Good. Thank you so much.
Hi, everybody. It's lunchtime. We have an hour and 12 minutes. If you're interested in the OKD conversation, that will be in Walnut 3. If you're interested in the post-quantum computing conversation, it will be in Walnut 2. Those are the two meeting rooms to the right. But the lunch is still served in Sycamore 2. Get your lunch. Go join those. The other conversations, the metrics, and the other ones will be at tables in Sycamore 2. Check 1. Check 2. Check 3. Check, check. Driving me nuts all morning.
Oh, that's my coffee. Yes, thank you. Oh, I see. Yes. I'm going to share it to the Mac side. Otherwise, like I remember, in DevConf, also like I think the screen might go, sleepy if I.
Yeah, that's true.
It's like, oh, you're not actually projecting. Yes, I am. Yeah, I couldn't get the projector to work from a VM. Weird. Of course, that was when I was using your UTM VM.
Mm-hmm.
And now I learned I switched away just before they fix it. Like, oh no, they do Apple virtualization. It's like, wow. How do I say shared with me?
I still use UTM for dealing with the weird old
Oh,
operating
God.
systems for the
How do I
PCs.
accept the thing I just shared to myself? Do I have to go to email?
Yes, you do.
Jesus. Why? Why is it not showing up in notification like in GitHub? Like, hey, somebody's sharing something with you.
You didn't get an email about it. Interesting.
Uh-oh. Yes, of course. I don't get an email because this, oh God. It's...
Oh, you can just take the link.
Yeah, exactly. It's
one of those things.
My email is special and Google doesn't understand it.
Mm.
Okay, crap. We have 1 minute now. Wonderful.
Worst case scenario, I'll just get my laptop and we can do that.
Yeah. And copy completion is a bit funny.
How are we doing?
Command completion on my fish on Mac. So. Come on.
How are you, David? Let's chat. Hey, are we... Oh, you're not plugged in yet to project.
I'll go get my laptop.
1 second. Yeah, we might have some technical issues. Actually, you know what? I'll just... If it works, it works, right? If it doesn't work, we'll switch to yours.
Hey, got it.
No, this is on the VM. We'll just...
Other side.
We'll just wing it and hope it doesn't break. If it breaks, then... Hold on.
Does it not like your HDMI port?
No, it's just very tight squeeze. Well enough? Here we go.
I can offer you a lapel. I can offer you a handheld. You're welcome to use that mic.
Neil walks more.
I walk.
You walk.
So...
We can get shirts on.
Yep. The Gordian knot? Oh, yeah. It sure definitely feels like it.
test. I think that works.
Huh?
Does that work?
I don't know.
Well, I know mine works because I can hear the reverb.
I think it works.
Yeah, I can hear
Let's
your
assume it
reverb.
does. Okay, good.
Hey, okay.
there
Let
we
me
go.
just look out the door here. I think we've got a good room. So,
Don't forget, we actually have the thing over here.
so we're going to start our
yes,
next set
but I need
of
to
sessions here.
be
We'll
able
have
to.
three
I forgot my
talks.
clicker.
After the next three talks, we'll have a break. We are going to do, as a reminder, a group photo to start off the break. The break should be really fun.
Okay.
But I think it is now 1:32, so I think it's good. So why don't we go ahead and welcome
Okay,
Michelle and Neil.
Hi, welcome everyone. Welcome back from lunch. Oh God, sorry. Today we're going to talk about our work and proposal, like improving how kernels are packaged in the RHEL Fedora space.
Yep.
So for those who have not seen us, I'm Michelle and this is Neil.
Hi.
We've been around Linux distribution world for a couple of decades.
Yeah, actually.
I think, yeah, like those are the relevant parts, I guess. Like I'm in the Fedora engineering committee. I used to be in the Apple committee. I'm in a bunch of other places. I dabbled in Debian maintenance as well. On my day job, I work in Linux user space at Meta, so I'm paid to work on distribution stuff. And Neil.
So, as I like to call myself, an open source advocate, and my day job is I'm a consultant with Velocity Limitless, which is my company that does open source stuff for people to adopt Linux and cloud and all that other fun stuff. And as part of both my personal and professional work, I contribute to a number of Linux distributions. The relevant ones are all up there. And as part of that, I do lots of things in those spaces. And you know, I'm big into desktop Linux, particularly in KDE, as well as in the systems management stack with RPM, DNF, Kiwi, Koji, OBS, and various other projects. And I have a podcast of my own where I talk about the business of Linux called The Pseudo Show. We relaunched it at the beginning of this year. Check it out.
Oh, neat. And I'm told that Neil sometimes sleeps.
I sometimes sleep. I hope I sleep more than only sometimes. Sometimes I don't either.
So background about why we are doing this. I work for a company that we deploy our own kernel, but we also like are on the cutting edge of some stuff, like deploying ARM on the server. And sometimes they require the latest and greatest of certain tools for to support like a hardware integration. So we need things like perf to be updated sometimes because like, hey, there's a bug like affecting only ARM, then we need a new version.
Yeah, and in my case, right, I developed the Fedora Asahi Remix, and that includes maintaining a kernel tree for that, as well as in the CentOS space, I do CentOS Hyperscale's kernel, as well as the Asahi variant for CentOS Hyperscale. And in these cases, I have to ship basically the latest stable release of the kernel with extra configuration and modifications to support the stuff that we're doing. Like what Michelle does inside of Meta, where they have this custom kernel and they have to have updated user space to go with it. A lot of that stuff also bleeds back into what we offer in CentOS Hyperscale, admittedly as optional stuff, but it still needs the leading edge kernel with those features available. And so my kernel in Hyperscale is basically the public counterpart to support this functionality.
For those who haven't poked deep into this, into the bubbles, this is how it works right now. Fedora used to have a separate kernel tools, which is the stuff that ships to the kernel, but it's not kernel code. It got rolled into the main kernel, just like it has always been in CentOS and RHEL, because it's such a pain to like
keep
have
them in
this.
sync.
Yes. And yeah, so RHEL and CentOS Stream has always had just one kernel RPM, which is good and bad.
Yeah, I mean, everything is updated together. It means that you don't have to worry about whether there's subtle drift differences or incompatibilities, or worse, an expectation that was compiled in and that isn't available at runtime. And it can go in both directions. Like if you have something built new against an older kernel, a lot of times it'll adapt and say, oh, I'm on an old kernel environment, and just never expose the new functionality, even if you runtime upgrade later. So it gets weird and stuff like that when you separate them. but and so that makes it really great, but
Yeah.
there's a lot more downsides.
Yeah, normally user space can be newer than the kernel, but
Yeah.
not the other way around.
And as we were saying, this is it's
On
a
the
lot.
other hand, yes, like you build everything together. Like it's really slow to build. If you want to make a change in a tiny part, you might have to rebuild everything if there is no toggle to disable everything else. So yeah, as we said, like you avoid version drift if you compile everything together, but the RHEL kernel is special and different components are backported, so it's already different versions anyway. And the version number you see in RPM lies.
Yes,
Well,
the cake has always been a lie.
The longer it's been since like a RHEL
Yeah.
got like a frozen,
Yeah,
it lies
and-
even more.
Yeah, the cake is always a lie in the RHEL CentOS world, and the difference is that how much lying do you want it to give you? And then there's the dependency explosion, right? The kernel code base itself actually doesn't require a whole lot. Well, I mean, I say it doesn't require a whole lot. It doesn't require a crazy amount of stuff to actually build itself, but the user space components are much more aggressive because these developers that are actually making the software are doing it on things like Fedora as opposed to RHEL or CentOS, and that means when we bring back newer stuff back to, like especially for CentOS Hyperscale, it becomes very complicated to make sure that we can actually build and release all these things. Like, there's a couple of examples of this. I think one was with
I have one.
Yeah, you have one with the YNL, and I have actually one with BPF tool and libbpf, which was that was not fun.
We'll get to it in a bit.
But the dependency explosion, the version drift thing, the dependency explosion is actually not the worst problem. The worst problem is it is so complicated that people can't figure out what the heck's going on inside of it when something fails.
And then like it's really hard to get people to work on the kernel like packaging because the spec is very intimidating.
Mm-hmm.
So what we have in mind is, I think I think I
reordered it. Yeah.
Yes. We want to make the spec simpler. Like since kernel RPM 4.19, you can use dynamic specs, so you can actually break a big spec into small parts, and you can basically
you can use template generation on the fly to make these various. So, for example, some Linux distributions, which notably I don't think this includes the Red Hat family, but like for example, the Mandrake family of distributions, their kernel packaging, they have this monster crazy macro that scares the crap out of me that lets it dynamically generate. Without the dynamic spec generation feature, that lets them populate all the kernel flavors from a template of spec magic.
They hand roll their own.
Yeah, they hand roll their own.
Oh, wow.
It's terrifying. I've never considered bringing it in because like it's so ugly. But like with dynamic spec generation, we can do this in a much cleaner way where I don't have to look like I have to escape like 3 or 4 levels of spec magic to make it make sense. So like being able to do this for kernel flavors, being able to do this for user space components and stuff, because as Michel does currently, he right now takes some of the user space stuff and builds them separately, but he has to keep all of the packaging instructions in sync. If we're able to do dynamic spec generation, we can actually just have a skeleton that does the user space ones that calls back into the main spec generation tools and do the right thing for each of those things. And having tunables and flags for being able to control which aspect has it also simplifies how you understand the build is being done, so debugging it is much more reasonable. And the moonshot idea, which I had a brain blast about this yesterday, was, well, if we do this right and we like do something fancy like send Koji the same build with a bunch of different tunables set at the same time, we can parallelize every step of this. So we could have the user space tools built and different flavors built all at the same time from different sets of different invocations of the same spec file. And because it would produce different results, it would be okay, except for your laptop decided to not be okay. Wow, Michel.
Yes, I moved country recently and they don't ship laptops, so I'm sorry, this is the only laptop I have.
So yeah, like being able to, we want to attempt, I'm not saying that this is actually possible or doable, but like the theory land in my brain says that we could possibly do this. And that would allow it to take, like my average kernel build times for ARM is like 4 to 6 hours, and I would like it to not be that long.
So yeah, we have numbers in a bit.
Yeah.
Yeah, but so that's that's what we propose to do. This work hasn't happened yet. The one that has happened is I have standalone packaging for a few things like perf and YNL. YNL is fun because someone wrote a Py project, .toml, which is really great. It works on RHEL 10 and above.
Yep.
It fails on RHEL 9, and we cannot update it because like setup tools you cannot update setup tools.
You cannot update setup tools beyond a certain point, and we hit that point a while ago.
Yes.
Oh.
So yeah, speaking of,
Yes.
like if you work on the kernel, then this will,
This becomes very legitimate.
Yes. So as a comparison, so like I'm taking the two tools that I've been like working on quite a bit recently. My standalone perf, the code is taken, the spec is taken from like yanked out from the main kernel spec. It's 263 lines. It builds in 2 to 3 minutes on both x86 and ARM on the official community build service. YNL is 140 lines. It builds in 1 minute, so you can see it's
it's fast.
Correlated. The kernel, and this is on the Koji that's powering CentOS Stream, which has powerful builders.
Yes.
1 hour on Intel and 2 hours on ARM, and it is 20,000 lines of code long.
Yeah, it is so much that like my eyes glaze.
So some of this, mind you, some of this is like, well, the kernel package is modular, and you package individual modules differently, so you can choose to not install them.
And
but
then
a lot
there's all
of
the
it is
filters.
hairy logic.
Yes, a lot of it's hairy logic. Some of it is, and a lot of it probably is templatable. Like,
Do you want to tell the story about BPF tool now?
Let's go. Let's
Yes.
go and talk about this. So,
how are we doing for time?
This 19,000 plus lines meant that there are 2 separate cases related to BPF that broke in the past. Like, one case was I think 3 or 4 months ago when I was working on the rebase to 616 and 617 was, well, we require the libBPF from the system to be able to build the BPF tool internally to be able to do the thing inside. I was like, well, on CentOS 9, libBPF is too old. And so we can't actually do that anymore. And so I have to patch back the logic to build it statically into the spec file, that we do it only on EL9 and older.
Because it bundles libBPF. You can,
it does,
you can,
but by default we don't use it.
You try to use a system one, yeah.
Yeah, so I had to switch it back. And then the most recent one, which Peter George here just told me what was going wrong, just like at lunch today. So for the past month, I've been trying to get an updated kernel shipped out for CentOS Stream 9. Like, the reason my presentation said that we were on 614 for CentOS Stream 9 and Hyperscale was because 615, 616, 617, and 618, I could not get it to build. And it's because there's a logic error in how BPF tool itself is built for the self-tests. And so the BPF tool that is used for the self-test is not a complete build of BPF tool, and so it breaks. And it thinks that there's no BPF tool to be available, and so therefore, I don't have a functioning kernel build. So, and the solution is, based on the comment that's above it that says, yeah, you should be ignoring the errors because they can fail. I'm like, why is this here? So, turn off the self-tests because apparently they are pointless. But they also constitute a major chunk of the logic inside of that spec file.
And this is a continuing struggle. Part of the reason we package something separately is waiting for an updated hyperscale kernel build takes a while because Neil doesn't have time to debug this every day.
No, I mean, the longest time that I had to spend was like 4 days of actually trying to get this to work. And the loops are so long.
Yeah, so this is our to-do list basically. I've been packaging a bunch of specs separately. The first thing we can do, this is meant to happen before FOSDEM, but things are busy at work.
Yeah.
That we can start feeding back the individual improvements because it's easier to iterate faster when you have individual specs.
Yep.
So that can happen quick enough as soon as I figure out how Arc actually works. Neil wants to basically start doing this thing where we start using spec parts.
Yeah.
At least for Fedora and
yeah. So my
11,
thought is that for Arc going forward for Fedora and ELN is I want to attempt to essentially rebuild the spec file to leverage more modern RPM features because essentially the way that the spec file works assumes that we're going to build this for RHEL 6, which is not something anyone's doing.
Did you say 6?
6. There are almost no new features in RPM after 6 that are used in the spec file.
Oh.
So like,
yes.
so like, there's no reason to hold back that far because Red Hat doesn't even backport the kernel packaging that far back. They don't even backport the stuff that's in Arc, in packaging-wise, to EL9. The spec file stays fully forked. So it's not going to come back into 10. So, but it will make my life easier because I ignore the spec file for CS10, and I just take the one from Arc. So if Arc is improved, then it benefits me for that. I mean, it'll still break it for CS9, but we can also just say we're going to stop.
Yep.
So, like, it's going to be beneficial for me, and I think what it will result in is if people want to debug specific flavors or build specific things or test stuff or experiment, it'll be a lot simpler and easier to understand and be able to reason through how the build actually works. Because that's the biggest problem I have right now. Is I like to think I'm somewhat smart. I kind of understand how software packaging and delivery works.
But reading the kernel spec.
But reading the kernel spec makes it hard. I do the 5-year-old thing of like using my finger to follow the lines of code, and it's still not enough.
You need a screen, you know, like a very tall screen.
I need a tall screen. Give me a tall screen.
Yeah, and I guess too bad. Like we were hoping Justin Forbes show up here so we can talk to him, but I guess we'll catch him later.
Yeah, at some point. Well, we might tell him to go watch this, and then and then he can scream at us later in Matrix.
All right, I guess that's all we have written, I think.
Yeah.
Yeah, so questions? We have, how many minutes do we have? We have 10 minutes for question.
Wow.
Wow, we finished fast.
He's got his hand up.
Uh-oh.
Oh, no.
Oh, no, it's David.
It's David. He's going to ask a hard question.
He wants an AL2
I'm
kernel.
probably not going to ask a hard question. I kind of want to softball. This looks incredibly composable, and it looks like a very interesting proposal. Is there what kind of things would you need for traction in the Fedora community?
So we have had this discussion on and off, and the one I had with Justin is like, hey, you know, like, can we package perf separately, because you can always use a newer perf in older kernel anyway, and the build is, and it's a bit silly, like pulling in Python to build a kernel just because
and Perl.
Perf, yes, Python and Perl, just because perf need it.
Yeah.
And I think it's basically like, what are the pros and cons, like what do we gain versus like how much is the effort of maintaining two specs, basically.
Yeah, and I think one way that I think we could.
The nice thing about spec parts is we can go at it slowly, right? Like first, you split them up into like different spec parts, and then you can say, well, how about this spec part is now like an individual like spec, and it's easy to basically like just reuse the code.
My thought would be, just off the cuff, is the idea of when we produce this, we can actually store a copy of the spec parts that we're going to do or the generator at least, in a sub package that you can then pull in and then run it inside of your perf or whatever.
Oof.
And that way you don't have to redefine the stuff twice, so they can stay in sync pretty easily.
Oh, right, yes.
Because like the other challenge of having two separate spec files.
I was hoping you're not going to say Git module or something like, oh God, no.
No.
Git module is this Git.
I am creative, not crazy.
Okay, so then follow-up question, would it be possible to just make this a composable build and flatten it into the spec file?
That is currently sort of how the spec file works now, except for so technically, the version of the spec file that exists in Git and the version of the spec file that exists in dist-git are not the same. It is already templated in Git, and then they generate it as part of the make dist command that you use, and so it re-templates and re-expands and blows the spec back up into its full form.
Yeah, I guess everyone using RPM AutoSpec already has this anyway, right? Like,
right.
There's
a little bit of that already going on, and the problem with this is that means you can't run the spec file outside of running the make commands and then producing it, which means you can't test it against Git snapshots very easily unless you merge the snapshots into the arc tree first.
So David, is your question more like, can you run a preprocessor and get a spec file that you can check in and build on older release that doesn't support spec parts?
In theory, we could do that. We could do the same
that
horrible
makes sense.
mutation magic that.
Oh, systemd does this.
Yeah, we can do the same
Yeah.
horrible magic that systemd does. We can do the similar mutation magic that that the Mandrake family does with their kernels.
Do we want to do? I mean, the kernel's already 19,000 lines.
Yeah, I don't really want to do more of those.
We can-
but
we should look at this.
We should look at it and
Yes.
see if it doesn't hurt or make our eyes bleed more than it already does.
Right now, there's not many use cases of spec parts. Like, we could only find systemd.
Yeah.
If anyone knows of anything, please let us know because we don't want to reinvent the wheel.
Yeah.
But yeah, speaking of letting us know, like these are where you can find us on the internet. Website, I'm on Fediverse, we are both on Matrix. And you can hang out with us at the Hyperscale SIG.
Yeah, that's the place to reach us.
Actually, add more questions, anyone else? Only one question?
I guess.
People are sold, I guess. Yes.
I bet they're I bet they're like on the edge of food coma. That's probably what's actually happening. Yeah.
A good excuse to have before lunch,
Yeah.
after lunch.
Yeah, exactly.
Yes. Thank you.
All right, is Scott in the room?
I don't need
I have 3 mics now. Oh, there you are. I could leave this. So we're just a couple minutes ahead of schedule, but we'll just roll into the next talk as soon as these guys are ready. Surely not, and there will be almost certainly no questions for him. Absolutely no heckling from the
Hello.
audience.
I probably don't need this, but
It's good for the recording.
yeah, that's true.
Yeah.
That's true. All right, let's see if Rel 10 will do this in a happy way. Oh, it's the other screen. Loud hubs save lives. Oh, yeah, there we go. Okay.
All right, you want to kick it off?
Yeah. So everybody please welcome Scott and Brian.
Thanks. Do you want to introduce yourself? So this is your talk, I'm just crashing it, so.
So my name is Scott McCarty, longtime Red Hatter, almost 15 years. I was sort of the lead product manager for Rel 10, and we learned a bunch of things in Rel 10, and now we're planning Rel 11, and I think we're doing it better than we did before, and so we wanted to basically talk about how we're going about doing it.
And I'm Brian Stinson, I'm the lead product owner for, on the engineering side for RHEL and RHEL 11 specifically, so.
Yeah, so we've been connected at the hip basically for a while now. Kick it off, Brian.
Yeah, so those of you who have seen one of my talks before, like I really do like to dig into some of the history behind some of the changes that we've gone through as an organization and as a community when we talk about building RHEL, because if you think of how things were going in RHEL 7, RHEL 8, that was completely closed off to the public. You would throw patches over the wall, put them into Bugzilla. Things may happen, things may not, but you didn't really have any visibility into that process. We made a couple of changes along the way because we opened up minor release development in CentOS Stream for RHEL 9. And then in RHEL 10, we had the opportunity to kind of apply that mindset to an entire major release. RHEL 10 was the first one where we actually started from first principles there. And that kind of let us progress a little bit. I think you can kind of see the progression of where we're going. And I like to look at this in terms of a timeline because one of our intents as the RHEL organization is to continue opening up as much as we can. And so we're going to talk a little bit today about the RHEL 11 planning process, what it looks like, and kind of see if we can get some help from you, the community, so that we can find ourselves more comfortable, working together on ideas that may be, unformed and kind of new. So go ahead, Scott.
Yeah. So, yeah, I'll start at this RHEL 11 thing real quick. So we kicked off RHEL 10 3.5 years ago, 4 years ago, whatever it was. It was a while ago. It was about 3.5 years ago, I should say. And basically we learned a ton about how to do this. And then with the advent of RHEL 11, I was actually already working on this. I was by myself for a little while there, a couple weeks before RHEL 10 launched. We'd already kind of kicked off RHEL 11. The word RHEL 11 was already getting sent around inside of Red Hat, and everyone was surprised that I had it kicked off that fast. But basically, you can think of RHEL as being a very big platform, right? That handles a lot of different hardware and software and workloads. And there's sort of these. If you looked at the RHEL 10 launch, it was really like this and a few other things that we talked about. But these were, think of them as like very big market problems that we wanted to solve.
And Scott, we showed this out to the public, a little bit early on. But I think one of the differences that we're trying to highlight here is that these were foundations for RHEL 10, these features for RHEL 10 were. They had been in discussion for a while and pretty well baked by the time that we actually took them out to the public. So.
Yeah, I think we first talked about them publicly in 2024, in the summer maybe.
Something like that.
But we had been talking about them for probably a year before that. This time, here we are 2.5 years before RHEL 11, and we're already talking about them publicly. So I kind of want to explain that, you might have seen pretty marketing stuff that kind of had this and a few other things on it. But there's also this idea that there's sort of these active market problems that we're working on that continue on from RHEL 10. Like PQC is not done, the command line assistant is not done, and boot C is not done. So we have market problems that we're sort of still tackling that go on through to RHEL 11, and they may get done before RHEL 11 launches. And so we're starting to evolve, in fact, even the way we talk about these. We're sort of calling these the active market problems. And then we're also starting to think about, I'll wait, but we're also then thinking about how we backlog market problems. And what does the process of a major launch look like? It's really basically going out and finding a bunch of backlog problems, putting them on the queue, and then starting to work on those as we progress towards the next major version.
Yeah.
But yeah.
And so one of the things, like I mentioned, those market problems or outcomes that were on the screen earlier, those were presented publicly, in the middle of RHEL 10 development. But like I said, it was, from our perspective, that was still a little bit too late because we didn't have the opportunity to sort of, to collaborate on the initial phase of generating those ideas. We think they were great ideas, to be fair. I think the Bootsy stuff, all of that went fantastically, but we've got an opportunity to talk about things a little bit earlier and be comfortable with a plan that maybe not doesn't look completely finished and is sort of open to more input earlier in the process. And so this is our pitch for helping us generate the 60% plan so that we can collaborate and refine these market problems as we get closer to actual execution in the RHEL 11 timeframe.
Yeah. And so even before we go into the next slide and talk about 3 that I want to talk about here, this is not everything, but this is the ones that we feel comfortable talking about at this point. And I should also do a little more history diving. In RHEL 10, I kicked off RHEL 10 basically by emailing a bunch of the product managers and saying, hey, you guys talk to a lot of customers, you talk to a lot of salespeople, you talk to community people. Use your judgment to qualify what you think we can do, what we should do, what we should do, and then what we can do, and use your judgment. And that was an open process, but it wasn't as open. In this one, we actually sent it out to a much wider audience internally, and you'll see we want to go even further in RHEL 12, basically, or whatever's after RHEL 11. But this is kind of how we got to this 60% plan. We basically took bunches and bunches, dozens of ideas that got sent to us, and then we had to kind of stack rank them and do a bunch of artistic stuff to get them to a place where like, these are pretty decent ideas now, but it took a lot of work. And then we had to bring a bunch of people internally along to be comfortable enough to say this publicly and start to try to share this as early as we could. And then these are the three that I think we feel pretty comfortable talking about right now. We know this constructible OS problem is a big one, and Brian's going to talk about it more deeply. I won't go into it, but the gist is there's a lot of hardware and software coming, and RHEL is built in a way that it's hard to add things in a major release. And we want to be able to do that better. That's the gist of that. But the other ones, this new beta program and improved RFE, right now, probably the primary way, I mean, RFEs come from all over the place, but the primary way is you have to call support, and you will file an RFE, and we look at those, and there's heuristics of how we go through all of that, triage them, et cetera, et cetera. But we want to improve that process, and we want to open it up to like some kind of digital process where like, since we have this idea of a digital roadmap, which we announced in RHEL 10, a beautiful outcome here would be like, oh, I see this thing is coming, you know, it would be cool if this other thing that's kind of related to that, and I could just say, you know, new idea, right? And like submit that would be pretty cool. So it's along that idea. And then I'll go deeper into the beta program, but the gist of the beta program is what we do today with beta is not really helping as much as we think it could. And so we're thinking about ways that we could go deeper with specific technologies instead of just throwing an ISO over the wall and saying, hey, test this whole thing and see what you like or don't like. We think we can get to a place where we can actually like do more targeted collaboration, basically.
And so for these strategic pillars that you see on the screen, like there's going to be a lot more of these that we sort of curate as an organization. But I think one of the key things in terms of process that may be different from in the past is we're actually having a more structured process internally to make sure that we assign a product manager and a product owner, you know, on the business partnering with engineering to make sure that this gets investigated properly so that we have the signal of whether something is, you know, actually going to happen or not. Like, again, this is new ideas that we're trying to figure out how to make decisions about collaboratively, and that's a key update in the way that we operate as an organization.
The other piece that I realized I forgot to say out loud was, you look at this is 3 market problems that continue on from RHEL 10 that we're still working on towards RHEL 11. Here's 3 new ones that I'm basically introducing. You can think of this as 3 from our backlog. These are all large t-shirt market problems. Like what we're tracking at this level are large t-shirts. You will see other medium and small t-shirts come out of other subsystem teams in RHEL, and that's all great, but these are the ones that we look at literally once a week. I'm already looking at these once a week with a giant team of our sort of RHEL 11 core team, which is 5 people, and then there's also a bunch of product managers that are in charge of these different market problems and researching them and getting market data, et cetera, et cetera. So we're already reviewing them once a week, and so that's probably important to say too. This is sort of where the ship is steering, basically. Yep. Even though there are you'll see a bunch of little speedboats coming off the ships. They just can't get too far away from the ship or they'll be trapped in the ocean. But these are this is the ship, basically.
And so just a little bit about some of the market landscapes that we're looking at, and to kind of give you an idea of how we arrive at something like constructible OS. You know, Scott kind of put together some landscape for us, and this is basically what we're looking at. We've got an explosion in hardware and software demands, you know, both on the platform side, but also from vendors and you know folks that want to partner with us as Red Hat and work with us as a community. But we're finding the need to be a little bit more flexible in what we produce, and so instead of generating this entire monolith that we call RHEL, we need something a little bit more flexible than that. And you can see there, we're already doing some initial steps and kind of nibbling at pieces of this problem with some of our partners already. So you've probably seen some activity out in the CentOS space around NVIDIA. We've got other folks that are participating in this area, but there's a wide software ecosystem that could benefit from a little bit more customization in the way that we actually deliver the set of artifacts that we call RHEL. And so, like again, we took this as a thought experiment of what would a constructible OS look like for to actually meet that sort of need, because we know that these different problems need different collections of components. So maybe different subsets of RHEL that exist already, or maybe even a set of new components entirely that we haven't looked at as an operating system, as we've kind of tried to be a little bit more focused about what we ship in the operating system itself. But the idea is, what if we transformed from a set of this predetermined set of software that we produce as an operating system, and then kind of think about it more like a bill of materials that you pull from already built components. And so you build something once, but then you define what an operating system is by that set of bits that you just built, plus a set of metadata and other things that you wrap around it. That kind of lets you take pieces that you need and make different variants of an operating system that you can deliver as needed based on the use case.
Yeah, and I could say, like, to give you a little more background and be as transparent as I can, if you think about my team, the product management team, there's probably roughly 40 product managers that are all going and talking to partners and different, every one of these, the things we listed here, there's people talking to Amazon, or AWS, there's people talking to Azure, there's people talking to Google, all of these software companies that we talked about. And they all want to say, hey, I want to deliver this custom solution with this partner. Like, I'd love to build a specialized thing with Oracle, or a specialized thing with SAP, or a specialized thing with one of the cloud providers. Or you could even think of something as simple as runners in GitHub or whatever. Like, there's all these places that you need to customize RHEL in these special ways. And these product managers want to basically bring this thing to market, right? And so you think about my internal business problem is basically helping my product managers get this thing to market. So it has to be easily defined and brought forward and basically delivered.
And our problem on the engineering side is that, we get, so there are about 15 features, I think, attached to this outcome already. And so that means 15 variants that we need to figure out how to sustain.
Yeah.
And, doing it the current way is certainly a lot of engineering. We put a lot of engineering work into, consolidating RHEL into one, single set of deliverables, and turning that into 15 is definitely a fair amount of engineering work that we need to figure out how to tackle. So.
Yeah. So does that one make sense to everybody? Like, the world is going this direction. We've got to make RHEL be able to do this, basically. The other thing, though, was my boss got excited about this. This was something we came out of the RHEL 11 planning, where we were like, the current RFE process could be improved in a lot of ways, we think, in that we have this digital roadmap now that we're literally showing people the next dot release. In fact, I don't know how many of you have looked at it. We have our first RHEL 11 feature is in the digital roadmap. It's a deprecation. So it's not a real feature, but it's a feature. It's there. Like, that's the most public we've ever been. It was like, we did that 30 months before the release. So I think that's pretty good. But it gives us the opportunity to, get feedback basically early, right? So we basically announced modularity. We're going to remove support for modularity. So that means we're announcing to the world, hey, we're going to cease the roadmap of development on that. So we don't need Satellite and Insights, Image Builder, and all these other teams within Red Hat to continue executing roadmaps on this. But wouldn't it be cool if you, as a customer or even a community member, could log in and say, don't like that, vote against it, down thumb, whatever it is. Provide some kind of feedback through this mechanism, right? Right now it's sort of read-only, but the idea of this RFE process is could we get net new ideas and get feedback on the ones that we're publishing, and kind of get a two-way door of information going there, so that basically, users and, of course, customers could provide this kind of feedback. So this is really about doing more sophisticated analysis and triaging of the RFEs, because if you end up ramping up the amount that we get, we need to do some more sophisticated data analysis to make these triageable, and then also getting a feedback loop where people can just submit them. They don't have to call support. They don't have to have their AI agent call our support and file an RFE. They can just log into a tool and create it. Maybe even create it through an MCP server. I don't know. We're thinking about a lot of things. But it would be kind of cool if you were working on something with Claude and you're like, hey, file an RFE for this. You know, it just goes files an RFE and then it shows up in my digital roadmap, and when I log in the morning, I see it in the PM dashboard. That would be kind of cool. The other one, so how many of you know what Bootsy is? I assume most of you, many. So Bootsy was, I would say, one of the cooler pieces of technology we've worked on since Podman, I'd say. Podman was my baby. But Ben Briard, who's another product manager on our team, my peer, he worked on that deeply. And we learned a lot about what it means to co-develop technology with customers. For all of the development that we do and how transparent it is, it's not as often that we work with like specific customers deeply on a specific technology. I would say Bootsy was one where like Visa got on stage at Summit, and some of the value propositions that they found, like one in particular, they have a fleet of servers, and it was like their entire update time went down to like 5 minutes from like 45 minutes or an hour-ish, and so it was like a massive cut. I had not really ever thought about reboot times at servers at scale, so like working on that with a customer made us realize that there's like value propositions to the technology that sometimes you're not even aware of until a customer battle tests it, right? And that was brilliant. We had the customer get on stage, we loved it. Then we put Ben Briard on another project called Hummingbird, which I'm not sure if any of you have heard of that, but have any of you heard of Hummingbird? A decent number. So think of it as tiny container images that we're working on that are hardened and have very minimal CVEs. But what's even cooler about Hummingbird is that Ben has been working from the beginning after they did the press release for it to collect customers, let them sign up, and then we've actually been working very closely with a subset of those customers, and they've been giving us specific feedback, and now there's like, you know, if this goes well, there may be 10 customers on stage talking about Hummingbird at Summit, right? Like, so we're building a pipeline and realizing that like, if you get let me explain it this way. Historically, we would just say, here's the 10.0 beta, you know, ISO. Go ahead and download it and tell us what you think. It's not very targeted. Like, people are like, great, I have an operating system. But if instead you're like, hey, we have this thing called Bootsy, it allows you to build, you know, operating systems as if they're a container image, and you're like, sign me up for that. You know, like, I'd actually work on that with you. Like, I want to work on a specific piece of technology with Red Hat that would actually help my business problem, not just like download the ISO randomly. So the idea here is if we could sort of pivot the beta program more to like, this would be the high touch beta program that really lets people help. And so again, if you could see this coming on the digital roadmap and you're like, oh, I want to file an RFE on that, or maybe you're like, actually sign me up, I want to help co-develop that. So like you can imagine that's like a level of interaction you could get to this. So you could have a deeper experience with us, or like sort of a lighter experience, or just say, great, I see it's coming, at least I'm aware. But that's sort of the idea of this new beta program, is pivoting it away from like an old 1990s style beta program, basically.
And so, like, really what this is about what we're asking from you as, you know, a large part of the community that we address from the RHEL side. Again, this is a new way for us to operate. It's an expansion of where we wanted to go, you know, from the RHEL 9, RHEL 10 era. And so I think the first thing that we would ask of you, and you can expect the same from us, is trust over certainty. We want to share our thoughts, our ideas. You know, maybe they're completely wild and crazy and don't make any sense at all. But we want to share them with you first so that we can work on them together. And so if you ever come to one of these talks or see you know, features and outcomes that we're presenting as a group, until we release RHEL 11, we're not quite done yet, and we've got plenty of work to do together. The second thing is honest feedback. Most of you run you know, plenty of real world infrastructure. We want to know about it because even if you're not necessarily a Red Hat customer, you reflect, you know, some of the same patterns that we see across our customer base, and that's valuable information both for us as Red Hat, but also for the wider community as we build things together. And again, like we said earlier, this is a 60% plan. We know that there are things that we're going to edit out. There are things that are going to magically show up in the middle of the next couple of years that we don't even know about yet. And so, you know, being able to set a direction as an organization, as a community, is really important for us. But it's not not something that we're signing on a contract or an SLA or anything like that until we get to release time. And finally, like a lot of the work that we have in mind, I said we're already sort of nibbling at pieces of things like constructible OS. A lot of the features we have in mind are going to be directly applicable to either existing special interest groups or new ones. And so one thing that we ask of you is, as you co-develop with us, do it in the CentOS SIGs, because that's where we can gather some of the most important information, along with things going on upstream in Fedora and places like that. But the special interest groups are really important, both to the minor release process, but also as we learn about the new majors. That's a key venue for us.
Yeah, I agree. And I would say, like, yesterday I was asking, like, Neil and Davide, I asked you guys about that desktop thing. I really am interested in this. Like, I'm not asking just to be, like, painful, about it. This is the time that we're investigating these like, marker problems and deciding if, like, is this one I want to put on the backlog? Like, and I just have to be skeptical and see if I really think there's something real there. But, like, I do think there's an opportunity to leverage these SIGs more than we have. Like it would be cool if, if one of the things in my market problem was like worked with CentOS Stream SIG, blah blah blah. Like if there was data in my market problems, that like showed that collaboration, I think that would be a successful outcome. Like I view that as valuable. That's really it. So I think Neil, your hand is right.
On a related note, is the work you're mentioning here happening anywhere in CentOS? Like, for example, the constructed OS stuff that you were talking about? Because that feels like it would be a good fit for a SIG.
Yeah, so I think some of the initial work is actually happening as part of the NVIDIA stuff that we're working on. That's going to be, one of the pilot things. I think future work has to come out. We don't know what the engineering work looks like yet for that. But it has to come out in the SIG space, I think, to make it successful.
Would you be able to say that going forward, you're hoping that the vast majority of development TRL would happen in a SIG first?
I don't know if I could say vast majority.
Yeah, it's hard to say vast majority.
I realize this is a commitment, but like you get what I mean.
Well, and I'll explain why. I'll be transparent about why, but you tell your idea first.
I think there are places for every activity that we need to do. Like some things need to happen in Fedora. Some things need to happen in Fedora ELN because of the major release bootstrap type of activity. But I think the special interest groups specifically bring us a set of value that we can't ignore for the things that are targeted at a bootstrapped major release and things like that.
And let me walk. Oh, no, are you finished? So like if I walk through, I'll just give you a very high level overview of like what bootc looked like from beginning to end. So like, I'll give you an this is a hilarious example, but like Dan Walsh got excited about Colin's work, took it to Matt, our CEO. They spent 4 hours in his office geeking out on it. And it was like, oh, we're doing this. Like, okay, so now we've got this thing going. We go and do market data. So like we're working with our market team that like will literally go out and do intelligence and do stuff. All of that goes in my market problem. I'm not going to work on that in a public SIG, obviously. That's sensitive information. But then, we work on our positioning and messaging and all that stuff. Some of that happens there. So that's like marketing work. That's not going to happen in a SIG. But I do think there would have been an opportunity along that development path. I think Colin and Ben did a great job working on it publicly. But like it would have been cool if that was in a SIG. And then you get closer to launch and again, you use all that market. The market problem collects a lot of things that are like way beyond the engineering work. And a lot of that's not probably appropriate for public. But I do wonder if, like, the features that retire that market problem, I think at that feature level, I could see a lot of that living. Some of those features could have totally lived in a SIG kind of thing.
Can I give one more example? Because I think I mentioned the NVIDIA case, and I think the CentOS SIGs are uniquely positioned to deal with vendors and people who act like vendors, because that's really what they're looking for is some kind of a collaborative platform to build on, and that's exactly the type of activity that I'd like to see more of in the CentOS project. We're doing a great job so far with that, but expanding that is certainly on the top of my mind for the things we can work on together.
Yeah.
So,
And I am looking for a way, or thinking about a way that we can expose more of that feature work, because I do think that's appropriate to be public a lot of the time. I mean, example is, another piece I forgot to go a level deeper. At that feature level, some of that stuff lives in like Colin's team where they're actually changing boot C. Some of it lives in the image builder team where like console.red hat, like some of that stuff the community cares about, some of it they don't, right? And so like it's all over. I probably have like, we have some leftover work for image mode. It's probably 10 features if I'm being honest, just off the top of my head. They live in totally different teams, you know, all 10 of those features basically. To make it really polished, fit and finish, and be done with image builder, it's gonna take, and those, maybe one of those live in a SIG, 9 of them live in all kinds of crazy teams inside of Red Hat.
Neil.
I don't understand what you were talking about with the slide about the composable OS with the 1 versus 15. Constructible, sorry, that word.
Sorry, that we try to choose a word that is not trigger people.
Sure, I totally get it. Like the flexible hardware and software, that one makes sense. But the constructible OS, I'm a little confused what you mean by that. Based on the words you were saying, it sounded like, all right, you're producing these components, and what you want to do is provide essentially a menu of inputs that someone could select and produce a deliverable that they would want to use. Is that what it is, or is there something further to that? Because like, I couldn't quite follow what you meant.
Can I start with what I want? I won't necessarily get what I want. I'm a PM, but
Sure.
like, here's what I want.
Okay.
Like, today the channels in RHEL communicate something to customers, but it's not super crisp, and it's always a compromise. Because what's in base OS has certain packages within base OS have certain meanings, certain packages within AppStream have other meanings. You could argue supplementaries where things that are not open sources. There's some meaning to this stuff, but it's pretty nebulous. What I want is I want package level understanding of all that stuff. And then I need to be able to, when you look at how a RHEL customer, actually any customer of Linux, let's not even talk about a RHEL customer, but any customer of Linux, it's about the app and all the dependencies on that app, and I don't really, sometimes I care where those come from, sometimes I don't. Some of them I am happy inheriting some responsibility for, but I still want you to package it. But like there's all these different, I almost want it to be like an insurance bill, where it's like I build the app, it pulls in a bunch of dependencies, and I give you your bill. And then it's like, here's the part you owe, here's the part we cover, and I would like to get to that level of granularity where I can show the user basically like what their
responsibility. Right?
Yeah, like if you pull in Apple, great. I want you to do that. I want your app to work. But like, here's your responsibility when you pull in this package from Apple, and here's your responsibility if you pull in this other one that doesn't get updated as often. Like maybe we can communicate that level of granularity.
So what that looks like a little bit more on the implementation side. We've been, and again, this is a completely new idea. This is why it's
yeah. Well, that's why I'm asking. Is because like I have vague ideas of something that's vaguely shaped like this, and I just wanted to get a better understanding.
And so like the way I'm thinking about it is like an operating system is basically a set of bits, a life cycle, and a support statement from Red Hat's perspective, because we have to make those sorts of claims.
And an API.
And you can't. Those two things, the life cycle and the support level, in RHEL currently they're not surfaced in front of your face as a consumer on the.
Sure, there's a document, but it's not actually integrated into the machine.
Yeah.
Yes.
And so basically what I'm proposing is that we sort of normalize that as part of the thing that we produce, and that allows us to kind
I'm
of.
slightly on board with that.
That allows us to kind of pick and choose different combinations and both life cycle them and support them in different ways. That is a very Red Hat problem, I'll admit, but the life cycle is certainly a general problem.
Yeah, and also I want another weird one that you probably don't think about is I want package and containers, because my workload, say I build an image mode server, it's made up of a bunch of packages inside of that, and then I have a container glued into that with a bunch of packages in that. I want to know for all of the packages and those two containers, what's my bill? Like, what do I owe? What does Red Hat owe? Like I would like to see that as a user.
That makes a lot more sense.
It's hard to explain this.
I know.
We've got lights up here, so I can't see you, but.
Yeah, so are you really looking into building an OS for an individual customer? Is this more of a SBOM type of thing? Because the former looks like modularity and all the
Yeah.
other
Yeah.
attempts that have been done at
The
that?
short
The
answer
thing
is
we don't know the boundaries yet.
we don't know the boundaries
and
yet. Yeah.
Oh no.
I can tell you where I feel
yeah.
stronger and weaker about the thesis. I will definitely say at the partner level I feel pretty strong, but there is question of whether we would open this up to general customers. Like, let's be honest, there may be a custom kernel in here, and we're working on a Copper repo implementation potentially for like image builder for RHEL. And so like imagine we work with one of our common, David, who has his hand up. We work with him, and he wants to put packages in a Copper repo that are controlled by AWS and then glue them together with RHEL. I definitely want to do that. I don't know if I give that to customers as well, maybe, but it does feel like you're giving them the keys to break things themselves in ways that maybe we don't want to do. I'm not sure is the short answer yet. I definitely want to do it with partners. I'm not sure with customers. I'm sure customers are going to ask me to do it, though.
Yeah, I'll add that I see this as a recipe, right? You
Yep.
are the Gordon Ramsay of RHEL. So
I would like to be Emeril Lagasse. Can I do BAM?
So, but I guess one of the things that I run into is that so beta is too late, right? Like
Yep.
that's
Yep.
already
too
already,
late.
Yeah, way
That's
too
why
late.
Hummingbird's already being tested now.
Yeah. So for my experience, one of the things that's been a really a big complication and why I want to see this happen more in the community space rather than in the RHEL space is that, like, for me to do a lot of that testing that is early enough
Yep.
means that I'm spending a lot of time providing
I'm chomping at the bit to answer this question.
weird credentials for weird FTP experience.
The implication here, though, is that I need some of this infrastructure of how RHEL's built to go upstream and be the same with the same authentication and the same tooling and the same everything. Yes, I agree on that. That sounds like a feature that I need to retire this market problem. But I need your help with that. I need the community's help with that. You guys have to adopt that if that's what you want.
And then follow up to that, marketing. Does it have to live on that side? I mean, there's definitely PII that you cannot expose, but there are percentages and incentives that you can provide to the community. It seems like that would be an important part of the CentOS marketing SIG.
Yeah. Yeah. I could be convinced of that. We're experimenting. We're still trying to figure out how much we can share. I will say I feel like I'm sharing as much as I can, even right now. Like, I'm definitely trying to err on maybe sharing a little too much as opposed to not enough.
Thanks, everybody.
So there were actually a couple of questions in the live stream chat.
Okay.
If you feel like going to YouTube.
Okay.
But there was no time. So.
Okay, we'll look at it.
So we'll have one more talk before the break. Dennis will talk about OKD, CentOS Stream, and the Yellow Brick Road. I assume it will be a wicked sing-along, I think.
We can.
I'm learning that for Constructible OS, you can get people excited about the lifecycle metadata so that they get on board about the bits. Because if you start with the bits, they're like, what the hell is this?
Yeah, that's fair. That's fair. What is this? There's supposedly a CentOS live stream. CentOS live stream. He said there was a couple questions in there. What was it? He said there's a couple questions in the live stream. Live stream day 2. Let's see what people said. I should make sure my sound is not on so I don't become the feedback loop guy. Let's see. What would these questions be? Live chat?
Maybe? You have to be logged in.
I am logged in, right? If I go in here.
You're still wearing a mic.
Oh, yeah, I am. You're right.
Lectern Okay, ready?
I think so.
Okay, please welcome Dennis Gilmore to talk about OKD and CentOS Stream.
G'day everyone, I'm Dennis Gilmore. I'm an engineering manager at Red Hat, and I'm here to talk about OKD, CentOS Stream. What? You can't hear it? You can't? Okay. Let me just get rid of that then entirely. Is that better? You can hear me okay? All right. I'm Dennis Gilmore. I'm here to talk about OKD and CentOS Stream and the journey that we've been on, which I called the Yellow Brick Road for funsies. The background for the slides I used Gemini for, so for full attribution, I did not design that myself, but I had some fun with Gemini to create the slides. Quick agenda, I'm going to just go through what OKD is, things we did in the last year, what we're going to do this year, and opportunities that are upcoming. So what is OKD? OKD aims to be a fast-moving, free and open Kubernetes. It is based on the same source code as OpenShift. It's built from the same repositories. It is much, much shorter lifecycle. We currently are shipping OKD releases every approximately 4 months, and they're supported for 4 months. So once we ship the next version, the previous version is no longer supported, no longer gets updates. You need, in order to keep with OKD, you need to constantly upgrade, but upgrades work really, really well. It's very fast moving. We aim to share the processes and toolings with OpenShift as much as possible. And that way, we can do it in the open. People can see what's going on, but it's also, one of the things that in my previous life, I worked a lot in Fedora, and Fedora and RHEL diverged massively in how they were composed and how they were built, and that was extremely painful. And I want to make sure that we never do that with OpenShift and OKD. And we ship a small operator bundle that includes some key upstream components and operators, but it's probably one of the biggest areas where community can contribute to OKD. So in the last year, we shipped 3 releases of OKD. We shipped 19, 420 and 421 shipped about 2 weeks ago, and OpenShift 421 is not yet shipped. It's due sometime soon, but it is not yet shipped. We've got that out. We moved everything entirely to CentOS Stream. Historically, we used Fedora CoreOS. I think 419 was the first, 419 was the first version of OKD where we had everything entirely CentOS Stream based. The versions before, a couple of the versions before that were the containers and the core OS were CentOS Stream, but you actually had to use a Fedora CoreOS to bootstrap the environment and bootstrap the cluster to get OKD installed and the CentOS Stream bits installed on it. With 419, we moved to SCOS based on which SCOS stands for Stream Core OS. We moved to that based on 10. We had boot images, which are actually boot C images. And so the only mechanism from 419 on to boot your system is the image mode stuff with boot C, which is kind of cool. The team grew from no people to 3 engineers in the last year, as well as a bunch of community people. We adopted MicroShift. I was about to say micro OKD. We had a project inside of OKD called micro OKD, and we kind of merged them together, and MicroShift became part of what OKD is and what we're doing and what we're shipping. MicroShift is a small edge-based instance of OpenShift, kinda. There's no console, there's almost no operators are supported. It's a very minimal edge environment that is provides just enough Kubernetes to deploy things on. So that was a large part of what we did in the last year. The big change was, one of the biggest changes is moving to SCOS 10 and having the boot images. So this year, this may actually end up being a very short talk, but this year we're going to move to Conflux. We're actually in the process of doing that now. I think as of just this week, we managed to get all of everything built and build a payload inside of Conflux, and which for those that I'm assuming most people here have an idea of what Conflux is. But we're going to finalize that move to Conflux this year. One of the big goals, we're going to move all of the containers to CentOS Stream 10. So currently, like OpenShift is, currently OpenShift is all RHEL 9. With 4.20 or 21, there is an option where you can use RCOS 10 as the operating system. We moved to CentOS Stream 10 quite a while ago. We're going to move the containers this year to CentOS Stream 10. So that probably will bring some fun and interesting challenges as we move off. I know CentOS Stream 10 is old hat to everyone here, and we're just talking about CentOS Stream 11 and what is going to come with that. But we're trailing along, and while we're moving fast, we're behind the times in some ways. We try to keep OKD relevant to OpenShift in that by being fairly close to CentOS Stream, we're ahead of RHEL. We're able to test things, find bugs. We hit a bug last week that existed in OpenShift and in OKD. We found it first in OKD, got it fixed. It's never going to be a bug in OpenShift. So it's part of where OKD provides some value to Red Hat and makes it worthwhile, the investment in making OKD be a thing and support it in the community. We are planning to add AR64 support this year, and in doing that, we want to. So one of the things that OpenShift does is we produce 5 separate release payloads. We have a multi-payload that supports installing in multi-arch compute environments where you can have like ARM and x86 in the one cluster. We have an x86 payload, an ARM payload, a Z payload, and a Power payload. For OKD, we want to only have a multi-payload, and that one payload will be able to just deploy and install on ARM or x86 and just work everywhere. Simplify what we have to produce and what we have to test, and give everyone options of what to come. I expect at some point we will start looking at RISC-V, because I think that will be exciting for community people somewhere in the future. One thing that is somewhat problematic occasionally with OKD today is that we use the release controller to produce the upgrade graphs, which the upgrade graphs just tell the OKD cluster you're on version 4.21-SCOS0 and 4.21-SCOS1 is now available. And a side effect of the release controller is it does a bunch of automated graphs, and it is not overly controllable and configurable in what you present available. If a CI job or a manually kicked off job is done that says, hey, I want to test from this path to this path, and it passes, the release controller just says, hey, this is a valid path, and offers it to you, and doesn't actually understand channels and things like that like OpenShift has. And a side effect of that is we have EC builds and a stream of EC engineering candidate, which is the development. So right now we've got 421 as stable, and we've got 422 as the EC builds that are available for testing in the next release. When you upgrade to the latest 421 build, you will automatically get offered to upgrade to the EC build, which is not necessarily ideal. I accidentally did that on one of my clusters once, and like, oh well, I guess I'm running the EC builds now. It's kind of like running Rawhide on Fedora. where, you know, it can fluctuate quite a bit, but yeah, I mean, it's not necessarily a bad thing, but it's, for people that, you know, particularly, you know, users, and our target users are very varied. Some of them are, you know, technologists that are running things at home and want to, you know, explore and use the latest greatest. They probably don't care if they're running an EC build. But we have some users that are in the back of the room that use it in production, and they probably don't want their production clusters to get upgraded accidentally to an EC build where it's, you know, not quite as fleshed out, not quite as stable. So Cincinnati is a service that enables you to manage and control the upgrades. We can create channels so that we can separate the EC builds from the, you know, the stable builds and provide mechanisms to, you know, give a better user experience to the users. As part of doing that, I would like to also, you know, we don't have a huge idea of how many people are actually using OKD today. I know that in the internal tracked growth shows about it shows a smaller percentage of, you know, the clusters. The overall OpenShift clusters are OKD. And it's growing, but we don't exactly know. You know, as Yum does with Mirror Manager, we take statistics from Mirror Manager to figure out, like, roughly how many people are using, you know, CentOS and Fedora and Apple and all of those different things. I like to use, you know, Cincinnati to create, you know, a mechanism where we can say, you know, based on who's checking into Cincinnati, we have an idea that there is, you know, 2,000 users or 5,000 users or 10,000 users or whatever that is. You know, I don't totally know how many. But that will offer us that. We also talked potentially about utilizing some kind of opt-in service where people could say, you know, because like Insights will tell you, you know, reports into Insights that you have, you know, so many CPUs, so many, you know, nodes and all that kind of stuff, and, you know, have an opt-in mechanism so that we get a better idea of our user base through that as well. We plan to become a certified Kubernetes distribution, which is something that OKD has not done today. I need to finalize some paperwork and make sure I can actually sign the paperwork before doing that, but that should be done hopefully in the first half of this year. And, you know, it'd be nice to say to the, you know, to the Kubernetes community that OKD is actually, you know, a certified thing, and we are part of the Kubernetes community and not just, you know, utilizing it and being on the, you know, the coattails of everything else. So one thing we've worked on a lot in the last year, and it's almost finished, is a OKD feature set. Feature sets in OpenShift are a mechanism where you can opt into tech preview features by enabling different feature sets. And we've been working on defining an OKD feature set so that features that are going into OpenShift and, you know, say like something that's intended to ship in 422, in 421 we can use the OKD feature set to say, make it GA in 421 on OKD, and that way we can, you know, get some better testing and, you know, a better idea of things and enable things earlier. You know, one of the goals of OKD is to enable technology earlier, let people do, you know, play around with it, explore it, find out, you know, how quirks, you know, niche edge use cases, stuff like that. And a big area that we're actually hiring a person in India, so if you know a person that's into AI and documentation and they're in India, we're hiring someone at the moment to work on improving the documentation. When historically OKD came out after OpenShift and we could just use the OpenShift documentation fairly well, but we're now, you know, we've been shipping our releases before for quite a while now, and we're slowly getting to the point where we should be around 6 to 8 weeks before an OpenShift release comes out, the OKD release will come out. And the documentation's generally not ready, so we're looking at using, you know, some AI and, you know, development stuff to go through the code and work on documentation, improving the documentation experience for, you know, the users and everything that we've got. So they're the big things we're planning to work on this year, and at least from my team that works on OKD. We have some opportunities in the OKD ecosystem to work on some different things. Enable more teams like the Microshift team doing their integration work and their upstream work inside of OKD, and just getting those teams more involved in it. It happens kind of by default because repositories and stuff are shared, but people don't always intentionally say, hey, this thing is turned on in OKD, let's experiment, let's push that out, let's make sure it's good there first. So that's an opportunity. So if you happen to work in any kind of space on top of things inside of OKD or in OpenShift land, want to make sure that people know that it's there and it's available. Want to work closer with different projects that are using OKD. So one of the big ones that's using OKD inside of Red Hat right now, there's a big team working on telco I think it's the Linux Foundation is the umbrella that it's under. It's called Project Silver. It's it's mostly European-based, open ORAN, and a lot of telco-related things. And they're using, with their last release, they published a whole bunch of guides on how to deploy all of that entire stack of software on top of OKD, and they're using OKD with SCOS and everything as their basis. And want to work with them, make sure we're getting good feedback, make sure we're providing what they want, and that they provide us with feedback as well. So that's an opportunity. We have some operators that are being worked on in the community. We have a thing called OKD operators, which is just operators for OKD, a stream of them that's quite opinionated, and a large part of it is open source versions of some of the Red Hat operators that are configured to run on some of KubeVirt, the operator for that. The community one in the Community Hub does not have the console integration with the OpenShift or OKD console, so having a version of that is configured to run and that on top of it. But we need to make sure that we have a really good defined way to contribute to OKD, to make the operators available, things like packaging guidelines for RPMs and stuff that's existed in the CentOS community for a long time, doesn't exist in the OKD community, and we need to set some of that up. And also want to engage with different providers to make it easy to try OKD. I know Oracle has some free instances and stuff available. It would be really cool if there's a really simple mechanism that anyone here could spin up a cluster in Oracle that's not actually going to cost them anything, and play around with OKD. And maybe that is Microshift just because of instance size limitations on the free instances and stuff like that. But it would be cool to, and I need to fix a typo in there because I apparently can't spell make today. Well, yes. Yeah. The text I generated, the images was Gemini, but yeah. So there's some of the opportunities that I see for OKD and some of the engagement that we can do within the different ecosystems around CentOS and Fedora and the Red Hat ecosystems and partners. And that's it. So we got some questions.
Hey, Dennis. So I love the idea of the Microshift. Microshift historically has not worked on cloud instances, and typically has required some sort of finesse.
Yeah.
And I mean, this is something that definitely think is worth doing, and I would love to be a part of that. So, what are the steps and stages of building out, from a community perspective, assistance in onboarding new members of the community?
That is an ongoing, so there is a OKD community working group. They meet every Tuesday. It's at noon Eastern. I think it's 6 p.m. British. Is that right, Zed? Yeah, 6 p.m. British. So I think it's 5 p.m. here. that's been an ongoing discussion, how to get contributors, how to get, active engagement within the community. There is a very small but passionate OKD community. Jamie, who is the chair on the cloud SIG within CentOS, he's very actively involved in the OKD working group. That is part of what we need to define, like how do we onboard people and how do we get people engaged.
So Red Hat has a certification process, right, around hardware, et cetera. How do we get that to work backwards into OKD?
Sure. So that certification, like the VCSP, the Verified Cloud Service Provider Program, is the engineering side of that is led by one of my other teams, and there's a tool called OPCT, the OpenShift Provider Certification Tool is what it stands for, and it does the validation, it spits out a whole bunch of logs, and we kind of go through it, and you need your, you need to set your networking up slightly different, or you need to make this in order, for it to be considered conformant and to work. That's all open. So in theory, it would just be a matter of getting somebody to analyze, the logs, and there's no reason why that work couldn't actually be done in OKD and in the context of OKD, and then go into OpenShift, and that's probably how it should be done. That like a provider does their development, they do their testing, they make sure that OKD works, and then magically OpenShift would work after the fact.
So I mean that sounds a little bit like making something available similar to the way that, say, Avocado used to be the thing for hardware on the rail side.
Yeah.
The future of operators, and you mentioned the OKD writer. Is there generally those live in an open source world closer to their provider? Is there a way for this is there a catalog that you're creating?
So OKD Orators is a small catalog of things. We do need to do some work to make that be enabled by default. At the moment, you have to opt in to use it. There is the community operators. The big difference between OKD Orators ones and the community operators is that a lot of the community operators are generically configured to run on Kubernetes, and they don't explicitly have things turned on that integrates nicely into the, for lack of a better word, the Red Hat ecosystem of Kubernetes, where you've got console integration and things like that in either OKD or OpenShift. And so OKD Orators, we've explicitly turning those things, doing builds of the open source community version of things, but explicitly turning on the feature set to enable console integration and stuff like that, so that it largely works like you would expect, the Red Hat version of it to be, but is branded for, the community side of things.
Okay. You liked your answer.
So.
What is the smallest single node operator that you were willing to support, or what is the largest microshift that you're willing to support?
So I think you could, there's nothing stopping anyone from running microshift on something that is bigger than, typically microshift is intended to run on like 2 to 8 gigs of RAM and like 2 to 4 cores. It's, designed for small nodes. I know, like ages ago I had a conversation with IBM and they were like, we've got these small edge-based things that we want to use power in stores, and we're like, oh, what? And they were wanting microshift, and they were like, well, how small is small? And like, oh, it's 64 cores and 128 gig of RAM. I'm like, that's not a small thing. That's a target for single node OpenShift. And you've got that already. We don't need to go down the route. Microshift is generally targeted at the small things. I run a Microshift instance at home on a little ARM SBC that's got a 256 gig NVMe, 4 cores, running it inside a Fedora because CentOS Stream doesn't run on that particular hardware. But it is designed. Microshift is designed for smaller hardware, but you don't get a console. You don't get a bunch of things because
operators.
And what if the operators are not supported and won't run on Microshift?
Yeah.
Because there's not enough resources typically in a Microshift instance. I think single node has a minimum requirement of like 16 gig of RAM, and that's largely because the console is somewhat resource intensive, and you run it on less than that, you basically can't really run a whole lot of workload, and you can experiment on less, and you get to keep the pieces.
Okay. Shipwright. Do you use Shipwright to build your operating system images as well as applications, or is there something else that you use?
So the SCOS is built in this same pipeline that builds RCOS, and the CoreOS team maintains and manages all of the SCOS deliverables.
Love that team. Great job, team.
Yeah, the containers and everything else have historically been built in Prow using a CI mechanism. We're in the process of moving things to Conflux, which uses Tecton.
And in your move to Conflux, are you working with the Bootsy team to make sure everything Bootsy related is in Conflux as well?
I've just recently had some discussions with the CoreOS team around their migration of things from their Jenkins and everything that currently builds into moving to into Conflux, and so that as part of their migration, they have to migrate our builds in that as well, and so yeah. So it will come, it will move, and it should be transparent to everyone in the end. All right, thank you.
Okay, hey, we are going to have our last break. I would like you all to do me a favor. We're going to take a group photo right out here on the stairs. This is how I proved to my boss that I was here working, and I wasn't just at the Belgian beer experience at the Bourse, which you should totally go to. So just join us out here on the stairs. I'm going to go grab the people from Sycamore too. We'll set it up. We have, in our break, in our final afternoon break, we've got, apparently, I'm told, beer and wine over there. So that's your reward for the group photo. We're going to extend the break a little bit, so don't feel rushed. We actually have some padding in the afternoon. So take group photo, get a beer or wine, juice, whatever you want. We have time.
That's fine. So I can take as long as you want.
Yours and the last one are both the 40-minute session.
Yep.
Oh yeah, Shimon's doing the.
So do you want a wired mic or that mic? And
Like you did your handheld, you can do a lapel, and there's that thing. So.
okay.
This should be okay. I'll take off.
Display detected.
That's good stash.
No, that's what it did yesterday.
Oh, okay. It's the exact opposite of a good start.
Yeah. I'm gonna try something I wanted to try. Okay. So if I look at displays.
Okay. This seems to be on.
Okay, let's see. Oh, that looks better. That looks like what it should be. But, aha! Yay! Keep that. Okay. So if I put it in over here, I so love. Let me do one thing. Let's make sure my screen doesn't turn off because it's going to be sitting here for a little bit. No, don't go to sleep. Don't dim. Don't turn off the screen. Okay, 30 minutes you can turn off the screen. Don't lock my thing. Okay, so sleep after 30 minutes. Okay.
That should be okay. So the change not
Yep.
slides anyways.
Yeah, but we got a few minutes. So page down, page up. No, let's click on there. Oh, silly thing. Page up. There we are. Page down, page up. Are you okay with that?
Yeah.
Page up and page down.
Are you able to use? Yeah, use these stuff.
Oh, are you
Arrows.
arrows?
Yeah.
That works too. Cool. There it is. I have searched my hotel room and my backpack for this. And I was like,
Okay.
should I do a handheld microphone or this?
What would you prefer, really? Either, right?
This is actually a good thing for me.
Yeah.
And then if I want to get loud or something, I can get close. David, this is your conscience. Give the new guy a big raise.
I agree.
How much extra time did you give him? I ran out.
He said. He just said,
Oh.
I think of extra time. I think he said there was going to be beer and wine. So.
Oh, great.
Maybe a while. I'm not sure if that was before or after, but we might have a rowdy crowd.
It'll be more rowdy than it already is. We are touching on all the hot points this in this talk. It's like, what's been controversial during this conference? Yes, that's in this talk.
That's most of this talk.
It is. I just threw in some of the things at the end, and then I'm like, oh goodness. What? I haven't actually looked at the live stream. How far over does it go? Is it the whole stage?
Let me check. I assume it's still live. Pause. Oh, we're on a break.
Oh.
Well, I should be able to rewind.
Yeah, they don't need two people screaming. So, how far over is the camera? That's fine.
I don't see a bit with people.
Well, if he's to the right of me, I'm going to use this microphone. Yeah. Okay. Well, do you want to be on the?
Yeah.
You want to be on the right of me, or you want to be on the left of me? I'm going to be
I think
right
the
here.
might work best with the mic there.
Okay.
What do you think?
Okay. Is it actually showing that? So if I walk over and point? Out of here? So if I point, I better use my mouse. Okay. No. Well, no, it's how should I be interactive? If it's a video of me, I will point, but if it's got the mouse, I will use my mouse. Cool. I'll do the mouse. Do you use the mouse?
Yep, I'll use the mouse for a bit of mine.
Okay. Whenever you're ready. Whenever everybody else. I was going to say, the crowd is just right as it is. All 10 of you. Oh, Fabian came in. Okay, well. Yeah. We were just. I can't hear you because the sound from there is actually coming right up the stage. So all I hear is.
That's what we can say when they ask questions. But.
Speak up! I can't hear you. Oh, they closed the door. I wasn't meaning to close the door.
I've been opening and closing it because it gets crowd up there and it's noisy and I close it. Then if I close it, it's shaky.
Yeah.
Maybe I'll just
To come in.
to come in or go over there to have conversation or
That's.
anything that's not.
Yeah, we got a couple more minutes. We can have a little conversation while we're here. When was it? Thursday. I was telling skiing stories, snow skiing. You probably don't snow ski in Ireland, do you?
No, most certainly not.
Do you water ski or?
No, there's not really much skiing or any water sports really in Ireland other than swimming would be the big one, especially sea swim. But no skiing. Surfing is a bit out in the water for it more. But yeah, it's.
I haven't skied since I grew up in Utah and I haven't
Yeah.
skied since I left.
Okay.
But I have lots of boring skiing stories. They needed a sound check, so I had to talk for like 15 minutes. And I realized, boy, these are boring. I used to tell them to the scouts. I was a Boy Scout leader, and that's how you get them to sleep, is you just tell boring stories. And they just like, I'm going to bed. I don't want to listen to you. But when I was a scout, I told exciting stories. So somebody asked me earlier if I'd been in negative 40 degrees weather, and I said yes. And negative 40 is the magic number, because it doesn't matter if it's Celsius or Fahrenheit, it's the same. Where I grew up in ski resorts. That's why I have skiing stories. And we would, several times a winter, we would get what's called inversions. So I was up in the mountains, in the ski resorts, that's where I lived. And these inversions were either a cold front trapped under a high thing or vice versa. And I'm not a weather person. Whatever it was, it meant it was insanely cold. It was usually negative 30 during the day and negative 40 at night, but it was also no wind at all. And it was so pretty at night because ice crystals would be in the air. Anyway, so we had a scout camp out. It was a Klondike Derby for those who did scouting in America. And we decided to do snow caves. So we had somebody had a little cabin, but it was about, what is that, 5 feet deep snow. So us scouts dug snow caves, and we didn't know how to really dig snow caves so that the heat stayed in, and it's negative 40. And needless to say, I was the first one that made it into the cabin. The scout leader stayed in the cabin. He's like, I'm not going to do a snow cave. So I was the first one in, and throughout the night, one by one, each scout, as they got cold, came in. So we weren't good snow cave people, and it was very cold. But that wasn't the coldest I was ever. So when I was going to high school, one of these inversions was happening. I lived up in the mountains, and there was a road that went up and down, and my high school was just on the other side. So I wouldn't hitchhike, but people see somebody hiking up this road, they're going to stop and pick him up. The problem was they closed the road. So I was coming home from high school. It's in Ogden. On the other side, it was about negative 25. So it's not that bad. But all I was wearing was a coat. A Levi's t-shirt, a coat, no hat, no gloves. So I'm walking, Adam might have heard this one. I'm walking up this thing, and there's a road closed sign. So I'm like, oh, shoot, this is going to be the first time I ever have to hike all the way off this thing. I get up about a half mile, and this truck comes up. And it's like, yeah. And they stopped, and they're like, do you want to ride? They said, we're just going to the top, because there's hiking trails at the top. And I said, sure. And they said, hop in the back. So here it is. It started at negative 26. We'll just say negative 30. And I'm in the bed of a truck going 30 to 40 miles an hour. So I got that wind freezing me. Then we got to the top, and this shade was already there. So it was negative 40 on the other side. And I start hiking down this thing. That was literally the coldest I'd ever been. My earlobes froze. I got about a half mile from the bottom, and one of the neighbors saw me hiking down the side of this thing, and that she came and picked me up, so I didn't have to hike the last half mile, but it was about 2 miles in -40 after I'd been in the back of the truck. So that was the coldest I've ever been.
And that's a wrap on CentOS Connect. Thank you, everybody. I love that Troy can always like fill time for me with the story. So, okay, we're going to get started again. We will have this session, one more session, and then we will have the closing where the waffle party details are revealed. So I see 20 people in the room that will be at the waffle party. So everybody, please welcome Troy Dawson and Sean Ryan.
Hello, my name is Troy Dawson. I'm the CentOS Stream team lead.
And I'm Sean Ryan. So most of you obviously know Troy, probably don't know me. I'm the newest member of CentOS Stream. So yeah, that's about it.
And we're here to tell you what's happened this past year. Well, a little bit more. For those of you who don't know what CentOS Stream is, it's a Linux OS maintained by RHEL engineers. Somebody wrote this, and I just loved it. And we're in charge of making it. Okay. A little bit more stuff. Those of you who know me know I love graphs. And there was that talk today about data and stuff. And this is the data I got. Well, what's interesting about graphs is we can look at, this is sort of accurate, is up to mid-January, is it shows that we had 3.5 million users of data, I shouldn't say users, computers that we could see. Now that sounds wonderful, but then you go, what are they doing with that? And this next one shows a little bit. The orange means they've been running for 25 weeks. So that's usually somebody's desktop, a server, or something like that. So I look at this and I go, okay, we got about 500,000. And to be honest, this is just the minimum numbers, but it gives us a basis of what it is. We've got about 500,000 computers running CentOS Stream all the time. You know, I run it as my desktop. That's what's running these slides. And, you know, other people do it as desktops. I'm sure some people do it as servers. Anyway, that's really cool. But then we see that this has actually stayed stable, those things. And a lot of people have been testing. The blue there is impure. Great, I cannot say the word. It's used less than a day. It's just, that's what the word means, just one day. So people are actually using a lot for testing. We assume they're testing for RHEL. They might be testing for CentOS Stream. We don't know. But anyway, people are using it a lot for testing, and that's good to know. It has nothing to do with the rest of this whole thing. So what's happened this past year, there's been a lot of changes in the pipeline. As end users, you really shouldn't see any difference. You're still going to look at the same logs. You're still going to, some of the logs might change. You're going to get the same packages and that, but the pipeline's changed. This was the pipeline last year. If you saw my presentation last year, I used this same slide. Things came in. Oh, there's my mouse. Things came in RHEL, Jira. This gets split. I'm not going to go into it. Go watch this thing from last year because that's not what it is. ROG happened. Sorry, that didn't sound right. ROG. R-O-G. RHEL on GitLab. That sounds terrifying, but it's not. It's basically, we switched from people using cent package, similar to Fed package, to start builds and stuff like that, to a merge-based workflow. So the way things work now is somebody, it could be one of you, it could be the maintainer, does a merge request. And there's some tests. Now, if we look back, and I should have put that on this slide, first things you're supposed to do is make a Rail JIRA ticket. That's one of the tests. So if anybody out here wants to get something merged, make sure you open the JIRA ticket and then do the merge request. I should have put that on this slide. So the merge request comes along. It does some preliminary tests. Is it, one of them is there a JIRA ticket? There's a few others. And then there's these things called draft builds. And you'll notice before it was built on CentOS Stream and then built on RHEL. Now it's built at the same time. Both RHEL and CentOS Stream are built at the same time. And we'll talk about draft builds in a little bit. It then goes through tests again. These are the big tests that say, hey, does this install? Does it do what we want it to do? And then it goes along, and the maintainer has the option of saying, yes, I like this, or no, I don't. And I believe some of them have it automated so that if it passes certain tests, they don't have to click it. But anyway, there is a point where the maintainer says yes, and if they do, it then gets merged. And then it's the same merge flow, gets merged into this CentOS Stream dискit and then into Rails dискit. But then instead of another build, these draft builds are tagged into candidate. So there is just that build. There is no more building. So what's tested is the actual packages that were built. There's no more of this, oh, the build route changed between when I did my initial tests and when the package was built. So anyway, that's ROG. And this is a little bit what it looks like. You got merge requests. Yeah, you can read that fairly good. And these merge requests, you'll notice they got these labels. And we're going to talk a little bit about them, but most of these say draft build, draft build, draft build, draft build. We're going to be going through libtiff, not libtiff. Sorry, it's too small over here. Oh, it is libtiff. Libtiff. And we're going to go through this particular merge request. So this is what it looks like. I'm going to look at the commit first on the merge request. You'll notice the commit has blah, blah, blah for CVE and descriptions, but the key thing is it's saying that resolves this JIRA ticket. So that's one of the tests, is it says, does it say it resolves a JIRA ticket or related to a JIRA ticket? There's a few other words. And if so, pass it. Well, pass that test. So there's the JIRA ticket that it sees. Now, we're now going to look at the pipeline. So this scrolls down quite a bit. If I showed the whole merge request, it was so small you guys wouldn't be able to read it. So go ahead and look at some of these merge requests on your own if you want. But we're going to look at the pipeline. I particularly like this pipeline, which is why I used it as an example. It's got 2 fails and then a pass. We're going to look at the first fail here. And the first fail passed all the initial tests. It's a little small for me to think. Check tickets. Discover test, pipeline, yeah, okay. But then this one, it built, the draft build built on CentOS, but it didn't build on RHEL. And you can go, if you want to, you can then click on that. Why didn't it build on RHEL? Usually, if you're outside of Red Hat, you can't see why it didn't build on RHEL. You can see why it didn't build on CentOS Stream, but not RHEL. Just so you know, there was a network hiccup and the package built, but when it tried to come back, it didn't. So, draft builds. I know we're in the middle of that merge request. It's an exciting merge request, but we're going to pause. Draft builds. What are draft builds? Okay, draft builds, for those of you who know Koji, Koji lets you have one NVR, that stands for name version release. So libtiff-1 for the version and -1.1 for the release. There can only be one of those in Koji. That's the way it is. And it's a good system. I'm not bashing the system, but there's a problem of, hey, you know what? I just had a network hiccup, and it built on one, and it didn't build on another. What am I going to do? That's where draft builds come in. Is that visible? Okay, I think so. So you'll notice, I'm going to make a big thing. This is, well, basically what we're attaching is the word draft with a number at the end for that thing. So this part here is all the same NVR, name version release, but then these different draft builds have a different number, so they have draft with the number after the end. It's pretty ingenious. I do not know who thought it up, but hats off to them, because they solved a problem we've had for quite a while. Let's look a little bit into them. If this first one was that one with the network hiccup, and you'll see this is the CentOS build. Like I said, you can see the CentOS builds, but not the Rail builds. And you'll notice that it's got, started and completed. But this other one that got promoted says it got started, completed, and promoted. And that's the new thing. So that one became this particular one. So that's what draft builds are. It's a simple concept, and that's what we're doing now. We're going to do a quick look at the other two things. So we're going to look at the second one, then the last one. The last one showed, hey, look, it built on Rail, and it built, that is what it's saying. Yep, CentOS Stream, and it built on Rail. And then it passed these tests, and then this one is the request. Basically, it's where the maintainer gets to look at it and say, yes, I want to do this, or no, I don't want to do this. But for this thing it is, and then he pressed, yes, I want to do this, and it got promoted. And there's your draft builds. So what else do we have? Oh, there's a word we haven't heard in this conference today.
Yes, it most certainly hasn't been a controversial word so far. So, first of all, yeah, I mentioned I'm the newest member. I've been working on Conflux for a lot of my time here. So, what this talk is going to be, it's going to be about what Conflux is and how it actually relates to CentOS Stream. So, it's not going to be a deep dive into the big problems that we faced or anything like that. It's more just a rundown of what it is and how it's affecting us. So, Conflux is a Kubernetes native build and release tool. So we're using it in CentOS Stream to build all of our RPMs now. So the main benefits of it is that the differences and the benefits is that originally Koji, it's traditionally tightly coupled with the release and the build. So in the same system, we're building it and then releasing. Conflux, we're building them in containers. We're decoupling the release and then, or decoupling the build, and then we're doing the release afterward. So the artifacts you can see, they're signed and they're policy verified, and then afterwards they're being pushed to Koji. So as I kindly borrowed or stole from Troy's diagram, where does Conflux actually fit in? So it's just in here, the draft builds. Everything else is intended to be the exact same. We're still using the traditional ROG pipelines, the dist-git, the candidates, the composers, they shouldn't change. It's just what's actually doing the system behind the build. So, an example here of an actual Conflux build that we've been doing. You can see it's pretty straightforward. It's cloning the repo, it's getting the build targets, and checking out what dependency it needs. It's doing for the multiple different architectures. calculating the dependencies, and then finally building them. This is all being done still through mock, and everything is kind of the same. Afterwards, we're uploading it to Quay. Luckily, Conflux has some features that if it notices, oh, this build has already been completed, it hasn't changed at all, we can then use Quay to download it rather than rebuilding it. So it's still going to have the summary and the SBOMs. So Conflux is looking pretty good. We're getting rid of Koji, right? Well, no. Koji is still going to exist. It's still going to be the source of truth, and it's still what we're using to look at for everything. All of the features in Koji are staying. It's just the system behind that's actually building the RPMs that are changing. So you can see here in the diagram of the build, if we just pretend this little red exclamation mark is a nice green check mark, it's a work in progress. It should be finished shortly. Work in progress. I'll hold my hands up. So it should be working shortly and will be handed over for that the community can actually test and see, make sure that we're not telling lies, that it is still the same. So basically, as I was saying, we're not changing anything too major from the contributor side. All the builds, we're still using Koji as the source of truth. All that's changing is where the RPMs are actually built, which is now in containers inside Conflux. And then the releases and the check-in is happening and then being pushed afterwards to Koji. So in the ideal world, as I said, none of you should notice anything different. You're still going to be interacting with everything the same before. Koji should be looking the exact same, and you don't need to learn Conflux to actually start contributing or doing anything. So yeah, a quick summary. It's Conflux. It's our new build and release platform. For the users, it shouldn't be changing anything. All that we're doing is the building of RPMs is moving out of Koji. They're moving into Conflux, but the releases are still going into Koji, and it's using mock as to build them. Koji is remaining the source of truth, and the existing workflows and everything are still staying the exact same. So yeah, Troy, I'll pass it back over to you.
Oh, all the fun words. So one question, is this implemented yet for CentOS Stream?
Yes, so it's not fully implemented yet. It's a work in progress, but it should be shortly. We've built a test RPM at the moment, and we're looking to move out to the wider rest of the RPMs afterwards.
Cool, thank you. There's other changes that are only halfway done, and I did not expect them to be so controversial at this conference this day, but we're going to talk about them. The first one that isn't controversial, thank goodness, images. RHEL has been building their images, and by images I don't mean the DVD or the NetBoot install. I mean the cloud images, WSL, wait, they don't do WSL, but we do. QCal images and stuff like that. But they've been building theirs on Image Builder for several years now. And we've done a lot of work to get them building on image. We've got the Koji plugin, in an Image Builder Koji plugin, and they've been building them on our infrastructure now. We do have some pungy problems, which is why it's not implemented. But that should happen soon. When that is, there will be some minor changes. I've looked through all the things. There's very minor changes, but at the time we cut over to those, do I have a page from that? Yeah. At the time we cut over to those, they will look the same as RHEL's images, and that was our thing. So that because people were like, "Hey, this image has this difference from RHEL." There will be some differences. They won't have Red Hat release. They will have CentOS Stream release with logos. They will not have subscription manager, or RHC. But other than those things that are purely rel things, they should be the exact image, and they should match the same, and we will be able to use the same rel configurations so that they'll match. One of the changes also is we're changing from image factory to image builder, so that's the name of them. We currently are building these images every time we do a compose. So you can get those things from the CentOS Stream Koji. So we're building there's CentOS Stream Azure, container-based, container minimal, EC2, generic cloud, Vagrant libvirt, Vagrant VirtualBox, and WSL. WSL2, if you're curious. Just go to the things like this. I don't know why I'm using my mouse. I can't really click on that. But these all have a thing called Gen 2 test. It's our generation 2 of images, and technically they're all tests, but they all work. So if you want to download them, you can. Take a test drive with them. Okay, that was the non-controversial thing. PQC. Post-quantum, is it crypto? Oh, it's not, okay. Post-quantum crypto. I sometimes say computing, but it's not computing. Okay, post-quantum crypto PQC. We do have keys for CentOS Stream 9 and 10. CentOS Stream 9 in CentOS, it's actually not in the CentOS release, it's in the CentOS release subpackage where the RPM signing keys are at. CentOS Stream 9, it is just a file in there. We have no plans on doing anything other than having that PQC file in there. CentOS Stream 10, currently, it's just that file there. There are plans in the future when bugs have been worked out and scripts have been rewritten to implement it. When that will happen, it's a lower priority in CentOS Stream than it was in RHEL. So our months, I'm going to say months. It's not going to be next week. Let me tell you that much. It's not going to be really soon. But when the final bugs are worked out, and we will try to announce it ahead of time on CentOS Devel. But for now, for both 9 and 10, they are in the things. They're in the Etsy PKI, RPM GPG key, CentOS official -PQC. So if you need them, that's where they're at. They're also on the keys page, on the CentOS keys page. Post-quantum crypto, everybody. Give it a hand. Secure boot. Nothing controversial about secure boot. Okay, the current secure boot in CentOS Stream 9 and 10 is currently working. We do know about the Microsoft thing. We do know the dates. Work is in progress, but we have no estimates. We really want to get it done by that cutoff date. We really want to get it done by those cutoff dates, but there is no estimate. Okay, just letting you know. If it gets close and we're getting scared, we'll let you all know. Okay? Is that enough for secure boot? Have I scared you enough? Thank you. That's it. That's all the changes we have done this year, this past year. Was that scary? I hope you guys made it through. Okay. Any questions? Everybody's too scared, or it's the second to last one. Everybody's too tired.
I'm not scared. No, just a question, because for me it was never clear, because I'm not contributing myself directly to a package. But assuming that I'm an external contributor, I want to have a look for the merge request. You said at first the contributor needs a Jira ticket, so you need to have another account to create in issue.redhat.com to create a ticket, right? So assuming that I do that, I have that, but assuming that I do that, I have opened a merge request, which is a minor bump of something. How can the test be run for the draft build if the person opening the merge request can't upload to the local-side cache anyway? So that draft build is failing because it's automatic, right? So it's failing because in your graph, the maintainer at the end can say yes or no and push to the local-side.
So let me make sure I got this summarized. You're doing a merge request. You've made the Jira ticket. You've done the merge request, but this merge request is a bump of like a version, so it needs the new version in the look-aside cache. I would contact the package maintainer.
Before to synchronize,
yeah,
before
because
opening the merge request, so that he can push first, so he pre-agrees to do it before the merge request.
Semi pre-agrees.
Yeah, otherwise the draft build would fail directly.
That is a good question, but yes, this is set up for mainly patches, for bumps in versions. I'm pretty sure the maintainer wants to grab that thing because he knows who you are, most of them. But if somebody, Mr. Hello over here, says, hey, I've got this tar ball with the new version, I'm pretty sure the package maintainer wants to go, I want to get it myself. So yeah, but if you do have it, contact the package maintainer through the Jira ticket saying, hey, it has that.
I wasn't paying attention to the contributor guideline, but maybe David did that because you know that's a work in progress for the contribution guide. That maybe something that should be written before. Otherwise, people would say like, "Oh, I would do this, I would do all the work, and then, oh, I'm stuck because I need to create another SSO account, and then, oh, but I'm not able to push anyway." And so that's like back to, oh, let's ping someone on Matrix directly just to solve that.
That is a good thing. Send me an email because with this talk, I've been rewriting it hasn't been published yet, those pages, because it is different than it used to be. So if somebody can send me an email to remind me, hey, make sure you put in about look-aside cache.
This is something we can fix on Monday when we work on docs, but we should do that.
Oh, that's right. I've even got a day to...
I do have an actual question, though, which is for you. Can we turn on draft builds in CBS? That would be useful, I think. Fabian says we can, so I will send him a ticket.
That's cool. Yeah, it's part of the code.
Set tag policy to not allow draft builds to be in arbitrary places. Yes.
We only heard half of what you said, but you said something about arbitrary.
NVR overlap is useful when you're very careful with it. If you're not very careful with it, it becomes very confusing very fast. So I strongly recommend that if you use draft builds at all, that you set a tag policy that limits where the draft builds can be used. You want to lock them in a box and only let them out when you want to.
Yep. Very true. Because, yeah, there's been so many times that the NVR policy has saved me and saved Koji a lot of compute time. I think, or somebody's just itching. Never mind. Are we done? I could tell another story, but I don't think you guys want to. Okay.
Okay, thank you.
Thank you.
One more. Do you want either of these, or will you just use these?
I think I'll use this one.
Great.
I'm okay.
That's easy.
That's nice. Yeah. So I think we should talk to the managers. Yeah, so I'm glad I still see people here. I think everyone here deserves a badge for sticking with us until now. Yeah, but now, having said that, I think we can start with the presentation. So, I'm Shimon. I work for Red Hat for 11 years already, and I work on the Foreman project. And that's what I'm here to talk about. It is a quite nice thing that I'm actually the last one, because it kind of encapsulates a lot of things that we were already talking in this conference. So what Foreman does? Foreman does provisioning, Foreman does configuration management, and configuration monitoring. Yes, I know monitoring is a very overloaded word. I'm talking about configuration monitoring, so we don't know how many CPUs are used or how many hours the machine runs. That's not kind of monitoring I'm talking here. I'm talking more about configuration. Either you have your configuration as you want it to be, and so on. So that's Foreman. So first of all, I want to go through the basic use case and what you can do with Foreman kind of out of the box. So you want to create a host. As we said, the first thing that we want to do is provision a host. So we want to create a host record in Foreman, and based on that record in Foreman, a machine will be created and provisioned. So first thing, we want to create a platform. We know how to create machines on almost any platform there is. So it can be a bare metal, it can be a local cloud, it can be an actual cloud, local cloud like VMware and so on. And it can be things on the cloud like EC2 or GCP and so on. So that's the first step you want to do. The next step, you want to describe which operating system you want on it. You say what operating system you want, you point it to an installation source where the installation will actually use where it will be installed from. You specify the PXE bits, really important because we use PXE boot underneath, so that's something that needs to be specified. You have to specify on which network all of this stuff will be deployed. So you have to specify a MAC address if it's a bare metal. If it's not a bare metal, it's easier. It will be specified by the compute resource. You have to specify the domain and subnet. Again, we will need to configure the PXE bits to match the operating system that you have chosen. So we will be able to actually provision everything. You click submit, and you will have your first host. So it's that simple. And that's the basic use case. This is how a host looks like in our inventory. So you will see the host, you will see which operating system. It has, the columns are customizable, so you can see quite a lot of things there. Okay, I know that not everyone wants to use provisioning from the get-go. People have their own ways of provisioning machines, have own scripts, whatever. No problem, we got you covered. We have something called global registration, where we generate a command. And by the way, everything that I describe here from the UI can be done by either API calls or CLI. We have those options also available. So, global registration, it spits out a quite nasty command. Sorry, tokens and stuff, security. Otherwise, it would be much simpler, much more readable. Anyway, you run this command on the machine you want to register into Foreman, and it does its own magic. It downloads some stuff from the Foreman server, and you will see the machine appearing in your Foreman, in your inventory. Now to the more complicated stuff. So first of all, Foreman has a pluggable architecture, so you can create more and more bits and add them into the mix, into your managing screens. One of the main plugins that we have, and it's heavily used, it's the content management plugin called Catello. It is opinionated, and it's there to ease the pain of managing which content gets to which server. That's basically the problem that Catello tries to solve. So especially in the world of streams where the packages are always updated in the underlying repo, I suppose it would be kind of a risky thing to run it in production. So for people who are actually don't want to have that streamline and have the bits downloaded under without I would say without a permission into their data centers, Catello can actually help here. So under the hood, Catello runs Candlepin for subscription stuff, which is less relevant for CentOS, and it runs Pulp under the hood to manage the content. So all the content management is done by Pulp and kind of wrapped with Catello concept above it. I will talk a bit about it later. So what is the concept? How Catello sees the world? So assuming you have an organization and you want to have your packages in it. So you have some development packages where development servers where you don't mind having the latest and greatest. Then you have some testing environment where you want to make sure that everything is okay and test that nothing breaks. And then, and only then, you would like to have those packages actually being promoted into the production, where when you are really sure about what versions of packages you have there. So this is the main concept, and Catello enables us to run this idea. Let's start with the terminology. So content could be quite everything. It can be software packages like RPMs. It can be containers. Yes, bootc is also pretty much supported in Catello these days. A repository, that's a collection of content, a collection of packages, or a collection of containers. A product would not be bound to a single repo. It can it can be split into separate repositories, so you would like to have your product as a collection of repositories. And hosts, those are the servers that are managed by Catello, so if you see host in the presentation, that's the machine that we are talking about that was provisioned, and we want to manage the content for it. So this is the main screen for managing Catello repositories. Quite intimidating, but I'll go through it. First of all, it gives you the statistics, what's underneath it. So it says how many packages there are, what kind of groups. It understands RPMs quite well. We have two ways of getting content into Catello repository. So you can upload directly. So let's say you have your own machines, you build your own packages, then you just need to upload the content. It will be uploaded to Pulp and then indexed in Catello. And once it's indexed in Catello, you can actually make it available to your servers. And there is a sync scenario where Catello actually requests Pulp that will download the content from the repo. It will fetch, it will crunch it, and then it will send the index back to Catello. So all the process is kind of automatic. So those are the repositories. So the consumption is pretty simple. The host needs a URL. It needs a definition of the repo on the machine itself. It will be pointed to the foreman server, to the machine, and Catello will manage that content for the host. So another bit from the Catello repo screen, you can see the sync settings. So where does it get its content from? So that's the source. And then you have the published at, that's the destination basically. This is where the content of this repository is available to others. Next concept is a content view. This one is a pure Catello. It doesn't have any equivalence in other projects. It's not something that Pulp exposes or anything. So the idea is that a content view is similar to a view in a database. So it can show you some information from multiple repositories with specific filters. So let's say you want an upstream with some packages excluded, or some containers that include only the latest versions and not some other tags that you are using. Next step is composite content view. Content views. Once you have a content view per, in this case, we have the example of a content view per application, basically. So you have a content view for a web application, for web server libraries, and for the base operating system. And then you have a composite content view, which is a single view into everything that is needed for a server to run your stack. So my software stack is a composite content view that is based on 3 content views underneath. Why is it important? You have to publish them. And this is where content view versions come into the picture. A content view can have a version. A version is a snapshot. So when you have a content view version, it will define exactly which versions of each package are, which versions of content would be the correct wording here, which versions of content are available in this specific content view version. Once you have that version, and as we have said, you can publish it. The same goes for content view, for composite content views, where you create the software's, the whole software stack, and you give it a version, so you know exactly what is going on all the levels of software. There is also the auto-publish, where if you update one of the content views that are underneath the composite content view, it will actually trigger another version update of the full composite content view package. So that's also an important part. Again, it enables you to have a single defined version of packages that are available to you, to the server. And the last concept I want to talk about is lifecycle environment. Lifecycle environment is the concept of on top of all the content views that we were talking about. So you have the library, which is the base environment that gets updates from outside, and you can publish those, you can promote those into a separate environment. So you promote those into your development environment. Once you are testing it, and you can discover all kinds of discrepancies. For example, you didn't know that you have to have a dependency on it. Okay, no problem. You create another content view version, and you promote this one this time. Now you can start developing your stuff. You have developed it. You can promote it for testing. You have tested it, and it worked quite well. So you promoted it to production. But then something in production fails. So this time, you can roll back only your production servers to the previous content view versions. Again, you have a proper full-blown version. You roll it back, and hey, your production still works, and you have the time to actually fix your dependencies and everything around it. So this is basically what this is the picture that you will get after such a move. So you will have a new content for development, the same content will be available for testing, but your production servers will run the previous version until you decide to promote the content to the production servers. Now hosts. This is how the host inventory looks like. When you click on a single machine, you will see this screen. So it will actually say which content view the machine is connected to. It will say a lot of statuses about the host, what happened to it, what's okay with it, what's not okay with it. I didn't want to go into all the configuration management details here, but most of it will be about the configuration of that machine. Since we do day 2 operations, we can run jobs on those machines. You will see the jobs that were run, some of them can fail, and you will see it again in a single screen. The same goes for errata. So since Red Hat publishes errata for packages, you would like to see what is applicable and what is installable on your machine. Again, that is after the content is promoted. Applicable and installable, the difference between those is it promoted to the machine and can the machine actually install it? The connection between the host and the lifecycle environment is done by an activation key. So each host has an activation key. The activation key is actually responsible for subscriptions, again, less relevant for CentOS. It has also the binding to the content view environment. Content view environment is content view times lifecycle environment. So you want a content view version something in lifecycle environment development. And it enables the machine to consume repositories. Now day 2. We have the option to, as I have said, we have an option to run remote execution, which means we can run shell commands or other types or Ansible playbooks on running servers. So you can select which command do you want to run. You can filter which machines will have that command on them. You can create a schedule for that, and you will see the reports once it's done. We can say, okay, I have a window at late night. Let it run on my service window. Once it's done, I will come back in the morning and see if it works okay. One of the things that we enable out of the box, once we install Catello on the Foreman server, you will have the upgrade job types. So you don't have to punch in the DNF commands and whatnot. It's boring. You can select which you can see that it's for a single host. You can see which packages are upgradable. You can select and say, okay, I want to upgrade all those packages on that host. Click on it, and it will run the remote execution under the hood without us needing to attend it. Now about errata. You can see Catello also gives you the ability to see the errata and apply it to machines. You can see all the details of it, what bugs it fixes, what CVE it fixes, and so on and so on, which packages are affected by it, so basically all the metadata. And this is the inventory, so you can see which machines have errata and installable updates available to them. So you can see if your machine is actually outdated and has some debt to be installed on, and you will see it directly in the inventory screen. So one of the problems is when a CVE is released. It will affect all the environments where the package actually exists. So you will see that all of your environments become vulnerable to that thing, and you will need to update them. So you know which CVE needs to be updated. So what you need to do is to add the CVE into your lifecycle environment and just create a new content view version for it, and then your content will be promoted directly into your host. So that's pretty much it. I didn't want to make it too long, especially not in this at this hour. So questions?
Remarkable similarity between some of the insights tools here. But what I'm super interested in is in the deployment strategies you have for this, are you are you building out support for the public clouds? Are you building out support for hosts on public cloud?
Yeah, we can deploy on public clouds. Foreman basically doesn't care what kind of hardware is there. We treat bare metal hosts as public clouds, as local virtual environments. So we work with EC2 instances, we work with the GCP instances, we work with the KubeVirt, VMware. There is a very active plugin on VMware, and bare metals.
Do you have plans to support lightweight virtual machines in the KVM space, the ones that are PCI-less?
I don't think we have a plugin for that right now, but again, it's pluggable. Most of our compute resources are defined as plugins. So, for example, KubeVirt is in a kind of development phase right now. So you can take that, copy it, and it's pretty straightforward to create one. So again, if anyone wants to take the lead on it, more than welcome.
Used Foreman a long time ago. Still happy that the project is still there. But the world has changed a lot, including in how you deploy your application, container, Bootsy, everything. So how do you see Foreman transforming itself to suddenly be the tool to deploy Bootsy image automatically, or container-based application instead of classical RPM like we did 10 years ago?
Okay, it's a complicated question. Let's split it into two things. So first of all, Catello can manage containers. We had a talk, I think, last year about it. Bootsy containers are entirely supported in as content type. So it means that you can actually manage your containers, and again, the same rules apply here as I was talking about. So you create your lifecycle environment, you create a content view with container tags, with the specific tags available to you, and then when the machine reboots, you can actually, it will reboot into the content that is available to you. So that part is solved, works, no problem with that. About installing bootable containers and so on, it is a more complicated thing, and we actually need to think about how do we treat and how we provision bootable containers. That's an interesting thing to have. As long as you can have, let's say it this way, if you can have Anaconda to actually deploy it,
it does.
We know. So
yeah, that's because I see Foreman is using Kickstart under the hood to deploy. Yes. So you can kickstart a machine bare metal, because we saw a Bootsy demo, but it was about converting an existing machine, but you can freshly install Bootsy directly with the Kickstart. Because Kickstart and Anaconda has the support to know, oh, it's a Bootsy I need to install instead of classical. So that shouldn't be a lot of work. If you just rely on a Kickstart that does Bootsy itself, that should be transparent for you.
Yes. Under the hood, I have, again, I was sparing your attention, but under the hood there is a huge template-based engine in Foreman that actually creates, that you create a template and it renders the template of the Kickstart file. And that's entirely customizable. So people could, so we supply some, of course, base Kickstart templates, but you could create your own. And you can bake in the Bootsy commands and Bootsy as a source and everything around it. So there is nothing actually stopping you from doing it. So yes, it's possible. We currently don't have that full use case available, especially since it's an open source project and we have to support more than just RHEL-based distros, so we have to support also Debian and so on. And we don't want to deliver features that are just RPM-based, and we can't support them on other distros. So that's why we don't have it as out of the box, but yes, it's totally possible. It shouldn't be too hard to implement. Yeah, then, thank you.
Okay, so I told you we had enough time, that we would probably still finish early even with the extra break. I am going to try to collect people for a closing, if you'll all just give me a couple of minutes. Troy, do you have another story? Can you entertain? I promise once I get this room full, I will be very quick in the closing. I don't want to be here for another half hour talking. So,
Okay, what do people want to hear about? What's kind of a story? You want to hear my scouting stories? Oh, or Amy?
No, I've got his slides.
Oh, whose slides? Sean's. I can tell a story about Sean's slides.
Sure.
Oh, talk in front of him. I can do that, maybe. Can I get a theme for it, though, so I can? Scouting? Okay. Scouting slides. Do you have the slides up?
I'm working on it.
Oh, okay. So I was a scoutmaster for 5 years. It was when my son started scouting 11 till he was 16, and it was great because, well, okay, that's cheating. I can see it right there.
That's the only one I'm going to show you right now, too.
Oh, okay. My favorite part about working with my son, and this isn't funny or anything, but when he started out, when he was 11 years old, you know, I was there for him, and you know, he'd get lost. Okay, my son has a terrible sense of direction, and I can say that in public because he knows it. He would get lost. I'd have to go find him and things like that. But then, like 2 or 3 years into it, I was having